Hi everyone, welcome back to Teradata Developer Training Series. In our today's session, we are going to learn about introduction to Teradata. So what is Teradata? Why do we need this Teradata? So how this Teradata will be used in our data warehousing environment, and the Teradata architecture. So what is AMP, what is Node, SMP and MVP architecture. Then we are going to learn about primary index concepts. If you haven't subscribed our channel, please subscribe the channel and click on the bell icon so that you'll be getting all the notifications. So let us start our session. Step is architecture. The second one is like SQL. Third one is like the utilities. Okay, utilities, and also practical experience on the things which are available in day to day, whatever we are practicing it, right? So even if you're having any doubts on Teradata, you can ask me. So if you have a very good experience on the SQL, then Teradata is very easy only. The thing is, the architecture wise, we have some differences. So those things we have to learn, and then creating the table also we have to learn some different things we have to learn. Okay. So first 2 to 3 days we are going to see like a theoretical class only. After 3 days or 4 days, we are going to see that completely on practical, creating a table, creating the utilities, all those. Okay. So my suggestion is take one notepad and pen. Okay. So whatever I'm teaching it, you can make a note of it. So this is what the agenda for today. So just we are going to see that introduction of Teradata and Teradata features, all those architecture, everything, how it will be the indexing, how it will be the storage, all those. The next session we are going to see that utilities. It's like a space, all those. Okay. So you know the Teradata, right? So why the naming call it as Teradata? So this is the first database in the database environment. It's the first database. We will call it as it handles the data in terms of terabytes, 10 to the power of 12. So in 1970s itself, they have started in California, and this is the first database handled terabytes of data in the year of 2000 in the era of 2000 handle the terabyte of data. So now the big data environment, they are handling it like petabyte, but this is the first database handled the data with the terabytes of data. Before Teradata, right, it was named as NCR Corporation. Okay, so that is the only company they have developed first. After that, Teradata has the company is acquired by Teradata, and from there they have named as Teradata Corporation in 2007. So that is what they have formed the Teradata Corporation. It is an American-based company. Okay, it's headquartered at California, and then they are operating. So normally Teradata, they mainly meant for data warehousing applications. You know already data warehousing, right? So data warehouse is nothing but it is used to handle huge volume of data. The historical data we will have here, we'll have our OLTP system. Instead of fetching the data for reporting, the OLTP, we have developed one system called OLAP. So this is like OLAP is for to handle huge volume of data. Why? Because, for example, if I have a company, to have the company analysis from the first day to till date, like last 5 years, last 10 years, or last quarter, last month, or last year, if I want to analyze it, then it has huge volume of data, right? The data should be handled. If I'm having only this OLTP, if I go and fetch the data for reporting, then this OLTP will get impacted. So that is why the company will have OLTP separately. They will not disturb this database. Normally OLTP, they will kept it in Oracle database. Whatever the transaction we do, right? For example, if you have online transaction, IRCTC or Amazon or Flipkart or anything, right? So whatever we are ordering it, everything will be handled by OLTP system only. Everything will be handled by OLTP at every frequency of time. We will fetch the data from here and we will load it into the OLAP. So for OLAP, for reporting purpose, it's for only for the management people. The management people, they will take report from this OLAP. Why? Because they should not take, for example, if you take Amazon, right? Amazon per second order is 800 orders per second. Think about 1 hour order, how many records will be created. So one order will create the backend 20, almost 20 records. the backend, approximately 20 records. But think about 1 minute record, 1 hour record, 1 day record. How many volume of record it will be created? So if I'm going to fetch like last 5 days of sales, it will be, this system will get impacted. To avoid that, we should not affect this particular system. To avoid that, we are every like half an hour or 1 hour frequency, we are pulling the data from here and loading into a OLAP system. Got it? OLAP system. So from there, I'm pulling the data for reporting. This OLAP system should have the capability to handle huge volume of data. So that is why we are going for Teradata. We are going for Teradata. Why? Because it can handle the data in terms of parallel. Okay, instead of in Oracle, it will be a serial, right? Serial of data access, it will be supported. But in Teradata, it will be parallel. So we have a process called AMP, so access module processor. So we will have multiple AMP on the Teradata. So it will be processed. So that is why the companies are going for Teradata for their data warehousing applications. So from this warehouse only, we are going for reporting like Tableau or ClickView or all those. So this is what the introduction of data warehousing, why they need data warehousing on Teradata. So that is why so multiple business will fetch the data from the data warehouse. So that is why the system should withstand this only for reporting purpose, not for the day-to-day business. This data warehouse, we will create it only for the reporting purpose. So if you take Teradata, we have different product from the Teradata Corporation. Okay, these are like data warehousing, database, okay, columnar database. So we have different utilities, right? So a lot of utilities are available. So application side, we have a lot of like Teradata marketing operations. We have applications also, Teradata. Even Hadoop also, we have Hadoop environment, Teradata application for Hadoop. Okay, big data environment also they have improved on nowadays. See here, big data analytics and Hadoop services, they have already started the services. That is why that the Teradata is used by the large enterprises, not for the small enterprises. And also the cost of Teradata is huge. Only the large, those who are handling huge volume of data, they will go for Teradata for their applications. And this is what the Teradata stands for, like with all the applications. Like nowadays, instead of Teradata, they have come up with big data also. But anyhow, it is on the, whenever we are going for huge volume of data, they are going for some Teradata applications. So we have different versions in Teradata. So normally Teradata 16 is the current version we are using in real time. So this is what the history of Teradata. 1979, they have introduced first Teradata, the database. This is the 1999 only. They have handled 130 terabytes of data. So this is the first database to handle 130 terabyte in 1999 itself. So even nowadays, some of the companies, right, they have data warehouse only on terabytes, like 130 or 1000 terabytes, all those. Okay. In 1999 itself, they have handled 130 terabytes. So 2008, they have introduced Teradata 13. Then 2012, they have introduced Teradata 14. Then 2014, they have introduced Teradata 15. And now 2016, right? December 2016, they have introduced 16th version, Teradata 16th version. So as of now, we are using Teradata 16. So these are all the main features in Teradata. The first main feature is parallelism. It has the architecture of MPP architecture. MPP is nothing but massive parallel processing. So it will do the parallel processing of massive data. So that is why we will call it as MPP architecture. And shared nothing architecture. So we will call it as Teradata architecture is shared nothing. I will tell you what is the shared nothing architecture after some time. It will have the horizontal scaling, not at the vertical scaling. It will have the horizontal scaling. So if any one of the node has been failure, the other node will take care. That is called a shared nothing architecture. For example, the data, I will tell you what is that shared nothing. Normally, we will go for this is, if you take, this is my database. This is my database, okay? Now it has something like 500 terabytes of space. You assume that it's a 500 terabytes of space. You want to increase 100 terabytes more. So normally if you are going for increasing it here. Okay, it's like vertical scaling. Now it will be at 600 terabytes, it will be vertical scaling. Instead of that, if you are going for vertical scaling, what will happen? If this particular system get hanged or something happen, all the 600 terabytes you cannot get it. We will call it like system halt. Then we have to restart it, and then we have to check some troubleshoot method to bring it. But if you're going for horizontal scaling, for example, whenever we are going for horizontal scaling instead of vertical, whenever you want to add it some 100 terabytes, you go for horizontal scaling this way. So this is like a box, Teradata box, a complete Teradata box we'll have. Within the box we'll have multiple node. So node we'll have. So each node will have the space, okay, Teradata space. So each node, assume that 500 terabytes of space. If one node has been failure, then whatever it has handled, it will pass that activity to other node. So this is like whenever this node, the failure mechanism we will see after some time. Whenever the node has been
then whatever the data in that node is there, will it be there any replicas of that
yeah,
data?
definitely we need to go for replication. So we will have the replication before that also. We have the fallback table, right? Fallback table, or so whatever the node replication factor we will have, we will define that replication factor in the Teradata box itself. So whenever it is storing the data into the one node, it will replicate the data, same data into a different node. For example, by default, the replication factor will be 3. If I'm going for replication factor will be 3, the other 3 node will have that, other 2 node will have the same data. If this node has been failure, the other node will take care that activity. This is like a fault tolerance. I will explain that data protection method. Okay. So this is like shared nothing architecture. If any one component has failure, the other component will work on. Why? Because it's an independently work, right? It is not dependent on the other one. So if it is here, it is failing, so entire it will get failed. But here it is failing, whatever the activity it has been handled, it will be transferred to the activity to the other node, and other node will take care. Then they will go for the, this is like hard standby node. Okay. Hard standby is nothing but whenever a node failure, the other node will take care of that activity, whatever the activity is handled, right? The other node will take care. It's like a stepney in the car. Okay. This is what it will take care, and each component in Teradata, it will work independently. So that is what the shared nothing architecture. And linear scalability. So this is what the linear scalability. We can go for linearly the horizontal scalable, right? Whenever we need to have the space, we can go for linear scalability. It can be scalable up to 4096 node. Now they have improved to 4690 nodes. So like this, they can go for linearly, they can go for 4096 node. Okay, parallel. And then connectivity, they have Teradata connectivity, they have the BiNet, right? So BiNet, it is a software and hardware component. So for the connectivity, they will use BiNet. BiNet will connect, it will interact with each other node, and also internode, internode node also. And we have the optimizer. This optimizer will tell us where the active data is present, and then whatever the data we are frequently accessing it, it will handle that. The optimizer will do that, the access path, everything. We will see that. Okay. So SQL, it will follow the ANSI standard. No other standard it will follow. So the Teradata will follow that ANSI standard. So it will be faster. Okay. So we have different utilities, right? The distribution, the data distribution will occur automatically based on the AMP we are choosing, number of AMP. Based on the indexing, data will be automatically distributed with other AMP. So this is what the feature of Teradata we are going to see in detail. So as I told, we have a lot of utilities are available. So either you can import the data or export the data from the database. Okay. So you are importing or exporting data from or to a Teradata. Okay, you can import it or you can export it from the database. So from flat file, if you want to load it into the Teradata, you can go for fast load. So if you want to load multiple tables at a time, you can go for multi-load. It's a T-pump. It's you are loading the data into a Teradata. Fast export, you are exporting data from the database. That is what the fast export. Okay, TPT, it's the Teradata parallel transporter. We will see one by one after some time. The utilities. So these utilities we will see, then you can understand clearly. The Teradata architecture, right? This is what the basic architecture of Teradata. Like this is what the architecture of Teradata, I think you have seen already. So it has four major components. One is parsing engine, binet, AMP, and storage. Okay, disk. So normally this is what the architecture of Teradata. I think you are familiar, but I will explain. The parsing engine is like a gatekeeper. Okay, so from the database or to a database. So whenever you want to take data from the database or you want to store the database, this is the first person to check your authentication, whether you are the logon. It will check your credentials, everything, and then it will parse that particular query. Whatever you are giving that SQL query, right? Select star from something. It
Yes,
will
yes.
convert that SQL query into a machine readable language, and then it will give it to the database. Okay, and also it will check the logon. So very first time it will check whether you are the authenticated user or not. It will tell that okay, it will pass on to the next over. Then parsing engine, and then it will check for the access path also. You are running the same query again and again. It will
Mhm,
it will store that query into one particular place. Okay, the access
mhm,
path it will place, and then you are fetching the same query. So anyhow it will store it in the RAM, and then it will fetch that query easily. So that is what the
mhm,
activity of parsing engine. Then you have the binet. Okay, so binet is nothing but Banyan network. It is for the connect. It's a hardware and software component on top of the wire, right? So within the database we'll have some hardware component. On the top of the hardware we will have some software component. It is used to do the communication between the modules. Okay, the modules component. And the AMP is nothing but it is the processing engine. Okay, it is a processing engine for Teradata. So access module processor is the acronym by for the AMP. So this is for the parallelism. Okay, so based on my index, it will distribute the data so to the data storage, where it will be stored, the data how it will be stored, and it will keep all the information for the storage and as well as retrieval. It will be important. You have stored today, after some time you want to retrieve, right? So for the retrieval
mhm,
it should tell that where it has been stored. So whether the data is there in the disk 1 or disk 2 or disk 3 or disk 4, it will have all this
mhm,
information. And also whenever you are doing all the arithmetic operations like
mhm,
the rank or arithmetic operations like the minimum of maximum of sum of the calculations you
mhm,
are doing, right? All the
mhm,
calculations done by using this amp only, this amp
mhm,
only. Then storage, it is used to store the data. So if you look at the storage, it will be a one hard disk only, one single
mhm,
database only. The single database is subdivided into logically, how we are having like C drive, D drive, E drive, right?
mhm,
It's a logically divided, but it's a separate component. But if
mhm,
you check the hard disk, it's one single component. Okay, the database is one single component. So you know, right? So if you take a database, the entire database, or sorry, Teradata database. So within database, you'll have multiple databases. In Oracle, we will call it like a schema. In Teradata, we will call it as database. Like in our real time also, we'll have different databases. If you are working for one particular database, this database only you will have access. The other databases, you need to get access based on your role. So you'll have so if you want to check how many databases are there, you have to go for DBC. So DBC is nothing but it's a metadata table. It will be mostly used for Teradata developer database computer. So that is the abbreviation for DBC. dbc.tables v. So we will have one session on DBC also. Okay, how many different tables are there on DBC? We will see one by one. So that you can get that metadata tables, you can have the idea on DBC. So this is a logical division of storage. The data will be stored in different disk based on the fallback, whether it will be stored here or the replication, it will be stored on different storage. We will see on the replications. Okay. So this is what the Teradata architecture. While inserting the data or while how many the parsing engine needed for this particular database, how many amp is needed, it's based on the number of node and also the number of amp they are using it. So this will be taken care by Teradata admin. It will be taken care by Teradata admin. But for example, if you have 6 rows of data, it will not store in a single storage, in single disk. If you have 3 different disks, It's all about unique primary index. We are using it. Then record will be stored in different disk only. Okay, if the row is 1 is coming here, row 2 will be going here, row 3 will be going somewhere, row 4 and row 6 and row 7. So this is what it will go. So this is what data storage as well as data retrieval. So this is the abbreviation for all those. MPP is nothing but massive parallel processing. AMP is nothing but access module processor. PE is nothing but parsing engine. SMP is nothing but symmetric multiprocessing. Okay, symmetric multiprocessing. This is one symmetric multiprocessing. This is one single SMP. Okay, the combination of this SMP is called it as MPP. Okay, combination of SMP we will call it as MPP architecture. One SMP may have multiple AMP, the parallel processing. Okay, here for the pictorial representation we have only given 4, but in real time you can check how many AMP is there. We have one query. Okay, the database you can go and check how many AMP is there for the particular database. Okay, I will give you the query for that to check the how many AMP is there. And then BiNet is a banded network. bteq is nothing but Teradata basic query. So this is what bteq script we have. So this is what the introduction. So now we are going to cover the different. So whatever I have told is a single data store only. Single data store, but logically divided. Okay, logically divided. So horizontally scaling and parallelism can handle the parallelism, and the parallel load and utilities we have. Fault tolerance, I told right, the shared nothing architecture, and total cost of ownership. We will say like it's a low cost for setting up, but it requires huge. The cost is huge only. We will call the Teradata, we will call it as low cost, but the cost wise when compared to other database, the cost wise Teradata is costly. The business intelligence, we will go for data warehousing, right? Star schema, Snowflake schema. We'll go for Teradata, and we will call it as intelligent memory. Okay, so Teradata, we will call it as intelligent memory. So what is that intelligent memory? Whatever the data we are frequently querying. Okay, so frequently querying, that the data will be automatically stored in the RAM of the disk, the database. The access path, it will be easily maintained, so it will easily fetch the data. So that is what intelligent memory we will call it as for the better performance. So this is the architecture of one particular node, one SMP. I told right, one SMP, and we will see each and every component now. SMP is nothing but symmetric multiprocessing. MPP is nothing but collection of SMPs. So this is one single node. This is one single node. Here we have 4 AMP, but in real time we have multiple AMP. You can check how many AMP is there in your database. You can query that. I will give you some the metadata query to query the database, and you can check it. Okay, and then SMP. SMP is nothing but this is one single SMP, single node. We will call it a single SMP. Then if you connect all the SMPs in the Banyan network, the BiNet, for interconnectivity of the node, then we'll go for MPP architecture. Okay, this is called MPP architecture. So MPP is nothing but it's a horizontal scaling. We will call it as cluster of database. If one in the cluster, if one node has been failure, the other node will take care. So whatever the task has been handled, it will be given to the other node. The other node will handle it, and then Teradata admin team, they will restart this particular node. Then they will bring it up, this particular node. Then it will take care the activity. After bringing up, it will act as a hot standby node. This is what the architecture. If you look at the architecture, we will call it as virtual processor. Okay, so vproc. So vproc is nothing but, see here, this is what the virtual processor. So one virtual processor used for the parallelism. Okay, the virtual processor is nothing but parsing engine and AMP. The combination of parsing engine and AMP is called it as virtual processor. So this one we will call it as virtual processor. vproc, the parsing engine and then AMP. So this is like one virtual processor, vproc. So sometimes we will call it as vproc. What is that? So vproc is a combination of parsing engine and AMP. So what is the functionality of vproc? To read the data. Okay, so read the data from the outer world to Teradata, or Teradata to outer world. Read and write operations. Okay, and then sorting. So while storing the data, if you want to store the data in the sorted order, then it will do the sorting algorithm, building the indexing, and loading the data into the database, and aggregations. I told, right? The AMP will take care of that aggregations, transactions and journaling, backup and recovery. The transaction and the journals and the fallback, backup, I will tell you after some time. What is that? The combination of vproc, we will call it as one single unit. Multiple vproc will be available. This is one vproc. The same way, this is another vproc, another vproc, another vproc. So the combination of vproc will be called as one node. The node will be called as MPP architecture. So this is what is the basic activity of vproc. It is used to do the parallelism. The multiple vproc will be available to handle that parallelism. Instead of doing one particular task by one person, the task by divided by into multiple persons, then it will be easily carried out. So this is what the virtual processor. Then what is the functionality of parsing engine? I told, right? Parsing engine is the gatekeeper of the first one. From the client to the database, the parsing engine is the gatekeeper. Okay. So it will act as a communicator between the client and the database. Client and the database through the AMP, and Binet. Okay. This is the parsing engine. The main activity of the parsing engine, the session control. It will check the log on and log off, authentication, all those. So in the bteq script, you are checking like log on, right?
Yes.
bteq script, first you will do the log on. First, if you are running the bteq script, the parsing engine will check the log on. Okay, whether the system is having that either sometimes a system account also may get locked, or system account may be expired. So that time, the parsing engine itself, it will stop that. Sometimes whenever you are executing the job and right, you will be getting error. Your session has been expired. The logon has been expired. So that time it will not go into the database also. The parsing engine itself, it will authenticate and then it will tell you what is error. Then the SQL parsing. SQL parsing is nothing but if you are giving some joins or subqueries, so you are giving some select star from something, right? It will convert that select star from into a machine readable language. The parsing error handling. If your query is having some error, some syntax error or logical error, it will throw. Logical error, it will not throw. The syntax error, it will throw. The parsing engine itself, it will identify that syntax error. It will not go into the database also. So error handling. Execution plan is nothing but, so how can I execute this particular query? Okay, so in which way? Execution plan. So you are executing the same query in daily, right? It will store that execution plan in particular place. If you are running the same query on daily basis, daily it will not check the execution plan. So one time it will check the execution plan and it will store it. Next time it will have the hash value. So based on the hash value, it will take that execution and then it will proceed with that execution plan. Then dispatch that query into a AMP. So whatever we are passing that query, right, it will dispatch with the AMP. So particular AMP. Then it will proceed with the result set to the client. So this is what the functionality of parsing engine. Got it? Then the Binet. Binet is like a Banyan network. This is what we will call it as high-speed interconnected network. Communication between all the nodes and everything. So linking the vproc nodes, signaling messaging, we will go for Binet. Then we will go for AMP. AMP is nothing but access module processor. Like each and every AMP is the main processing unit for the arithmetic operations. So virtual processor, the vproc, right? In the vproc, is the main component. Okay, manage the database, handle the file task, manipulate the task, all those it will be handling it. You have the locking system, right? So you will have the table locking. If you want to read that data from the table, you will make it like read lock. If some process is writing data into a table, you will go for write lock. Then no other will at the same time they cannot do the write into the table. Okay, read lock, write lock we will do, and then you can we will see that what is that locking system, and then joining, sorting, aggregations, journaling, the space management, everything will be taken care by access module processor. Then storage will be taken care by storage, and we do have one the software component, we will call it as PDE. PDE is nothing but on top of our OS, right? For example, in real time, on top of Linux OS, they will be installing that Teradata. The Teradata need to communicate with the OS also. The Linux OS and then Teradata, it needs to communicate on database. So that connectivity, this PDE will give us that connectivity. Parallel database extension will give us the connectivity between the OS and the database. Interaction between OS and
What about Windows? And Windows we can run
Windows.
this.
So here I have installed on Windows, right? But in real time, it will be installed on Unix only, not on Windows. So Windows, we have only the client. For example, this is the database server. This will be mounted on Unix OS. This will be mounted on OS, right? In our system, it will be mounted on OS called Windows OS. But in real time, it will be mounted on Teradata has been installed on Unix or Linux or Red Hat, all this Ubuntu, all the operating system. Okay, any one of the operating system. The interaction between the OS and the database by taken care by this PDE, parallel database extension. So now we will start with the indexing. So I told the data has been distributed, the automatically distributed. The features also we have seen, parallel distribution will take care that automatically, right? How the data will be distributed automatically based on the index only. Create index, or you may not create index. Teradata itself, it will automatically create an index for the table. First column, it will take it as a indexing column. So sometimes in our real time, if you don't create indexing, it will take it as no PI table. No PI table. No PI is nothing but no primary index. So in our database environment, they have set up like if you don't mention any primary index, you take it as no PI table. In our environment, they are using like no PI table. So nowadays they are using like no PI, but it will be differ from project to project. In your project, they might be using the first column as primary index. In our system, right? If you don't use that primary index, first column will be taken as primary index. So you assume that you have the data. So you have the data in the table, some data in the table. Based on the data, it will be distributed. Okay, it will be distributed. So you have customer table. Assume that you have customer table. You have customer ID. So assume that you have unique customer ID. So you have unique numbers. Okay, unique numbers. You want to store this data into a database. So each and every record is unique, right? So based on that Unix value, it will have some algorithm to divide that data into a different AMP. Okay, something like modulus function or something, it will have it. If I have 4 different AMP, then this will be divided into 4 different the AMP. Okay, so it is going to AMP 1. Okay, you assume that this is going for AMP 1. This will be going to AMP 4. Okay, this will be going to AMP 4. This will be going to AMP 3. Then again it will be going to AMP 2. So this is what it will go. Then again it will be repeated. To be repeated for next 4 records. Got it? So AMP1 and AMP2, AMP3 or AMP4, it will be repeated. So parallelly it will distribute the record. Same record, if it is, this is called indexing. Based on the indexing, one record will go to the one particular AMP. Correct? It will not go to the same AMP again. The same record is not repeating it. So it will go to the different AMP. If one record is coming here, it will go to AMP1. Next record will go to AMP2, AMP3, AMP4. Then again, AMP1, AMP2, AMP3, AMP4. It will be, again, it is not on the order. It might go to this way also. So this is called the distribution of the data. So parallelly, it will be distributed. So whenever the reading the data like AMP1, the same instant AMP4 will read the data. AMP3 will read the data. So at one single instance, the 4 data will be written. One single instance. So second instance, it will read the data. Third instance, it will read the data. So this is what 3 seconds it will process 12 records now. Okay. If it is Oracle, only 3 records will be processed. But if in Teradata, it will be processed like 12 records. Got it? This is like 1 AMP operations. Why? Because like if I'm having like the record, it will be only one the record will be stored in only 1 amp, right? It will not be stored the other amp. This is called 1 amp operations. If it is not unique primary index, you assume that if it is not unique primary index, it can have a duplicate also. It can have duplicate also. The same record can be repeated. The same record can repeated. Whatever the amp it has been loaded, the same amp it will process. It will go to again on the same amp, not on the different amp. So again, if it is record is coming the same record, again it will go to the same amp only, amp 4 only. This will be taken care by that algorithm. I will show you that algorithm. Okay, the algorithm takes place to the particular amp. It will go to the same amp. So even though it is a UPI or the PI, it will be a 1 amp operations. Got it? What is meant by 1 amp operations? So it will be 1 amp operations. The 2 amp operation will be on the secondary index. I will tell you. So now the 1 amp operations. What is that 1 amp operation now? If you look at here, the database, the primary index. The primary index is nothing but, so based on it's a mechanism to assign value to a particular amp, particular disk, the path. Okay, the access path for the particular. So entire table, it's going to be distributed within this particular amp. Okay, so while creating the table, you have to mention which is the primary index. If you don't mention, so you can have the combination of column also. So you can combine 2 or 3 columns as one particular primary index. So the combination of value will be stored in a particular amp. Only one primary index, but you can have multiple columns in the primary index. Only one primary index per table. Only one primary index per table. So primary index value can be unique or non-unique. This is the value, right? This is the value. This value can be unique or non-unique. If it is unique, then it will be a unique primary index. Okay, if it is a non-unique, it's a non-unique primary index. So primary index, we will call it as non-unique primary index also, the other word. Okay, and also the primary index value can be null. Okay, if you are making like this column as primary index, you can accept null value also, null also. So it can accept null value also. The combination of, so all the null value, it will go to one particular amp. More value is coming. That is what the skewness. For example, more duplicate value is coming. Something like more this value is coming. Where all the value will go to same amp, right? All the value will go to the same amp, amp number 4.
Yes, correct.
Same disk it will go. So this is called a skewness. One disk will have more value. One disk will have more value, right? This is called skewness. We will call it as tables are skewed. This is like not a skew table. Based on the, if you are not selecting the index is proper index, then see here, the record is going to the same amp, right? So this will be a skewness. We will call it a skewness. Skewness is the name, the statistical name, how the data distributed among the disk. Okay, this is called skewness. So we will come to that point later. Skewness will happen if you don't select the index is the correct index. Okay, if you are thinking that this column will have more duplicate value, you go for one more column. Okay, customer ID and mobile number. Combination of this column you create for indexing. That is why in real time they will have combination of column for primary index. So they will call it like primary index of these two columns, like customer ID, comma, the mobile number. The second column they will give. Even third column also they will give. So combination of this column will not have duplicate, right? One customer may have, if they have two mobile number, it will be going to the two different amp. It will not go to the same amp.
Yes.
So that is why the data will be eventually distributed. It will not get any skewness. If you get skewness, one amp will have more operations, then it will struggle to fetch the data and also struggle to load the data.
Yes.
So that is what the skewness. Got it?
Yes.
So primary index value can be modified. Okay. If you have already created the table, the value can be modified. From this value can update. Some other value can update it. Value can be updated. But after creating the table, after loading the data into a table, you cannot modify it, the indexing. If the table has record, right? If the table has record, you cannot, for example, first of all, you have created index by customer ID, primary index of customer ID. After some time, you want to change it customer ID to mobile number, the indexing, or combination of the column you want to create it. The only thing is you have to either you can drop and recreate, or if it is a final table, you will take the backup of the table, you will delete all the record from the table, you will modify the indexing, and then you will restore the data from the backup table to normal table. Okay, that is what you will do it. So this thing we will do it in the real time. I will show you. So this is what.
Like we cannot change the different column name as the primary index
Yeah,
without
after
dropping.
creating the table, if the table
Yeah.
contains data, if the table
Okay.
doesn't contains any data, it's a blank table. Okay, you have created the table with the primary index of customer ID. It doesn't, you haven't loaded data as of now. You can modify it.
Okay.
You can
With the
modify it by
data, we
using,
cannot change the
with
column.
data, you cannot modify it. What we will do, we will take the backup of this table. Okay, for assume
And
that we
we'll
will take the
plot the
backup of
table
the
and
table. We will,
okay.
we will delete all the record from the table. We will modify it, or you can drop and recreate also, no issues. Since
Okay.
we have created the backup, right? So after that we can create drop and recreate. We have created, and then again we will restore the data from here to here. So this is what we will do in real time. Okay. Sometimes the DBA will tell us the table is going for more skewness. You look into the issue. That's at that time you will go for the operation. And also sometimes we will have some spool space issue. I will tell you what we need to do that. But skewness, this is what we need to do that. You check the table, so how the table index has been, duplicate record, you check for that particular indexing column. If you have more duplicate value on the particular index column, you can assume that there will be a skewness. Okay. So you have to choose some different indexing. So this is like a primary index. So this is what the rules of primary index. I told, right? Employee ID will be a primary index. If you want to create employee ID alone, you can create it employee ID. Or if you want to create like a combination of the indexing, okay, like employee ID PAN number, then employee ID date of birth PAN number. It's like a indexing, okay, primary index of first name, last name, date of joining. The combination will not repeated again. The index can be divided into two different index. One is unique primary index, non-unique primary index. Unique primary in the sense, if you are assigning a column as unique primary index, that particular column will not allow duplicate. It's like a primary key. Okay, if you are assigning a column as unique primary index, that column will not allow duplicate record. So non-unique primary index is nothing but simply you are creating a primary index, right? That is non-unique primary index. So the primary index value can be null. Okay, but the index, so you cannot, if you are after creating the table, if you are you cannot modify the index. If you want to modify it, then you have to go for whatever I told, right? The backing up of the table and that also.
Yes.
So primary index, you can go up to 64 combinations of columns. Like I told, right? This is the way you can go for the combinations, like employee ID are 2 columns, 3 columns, 4 columns, right? The same way you can go for 64 different columns you can go for. And how can I create the index? So in the create table structure, at last primary index of the column names. So either 1 column or 2 column, you can go up to 64 combinations of columns. So this is what the indexing. So what is that? So significance of primary index, I will tell you the next session. How the hash value will be generated, how the data will be distributed. I told, right, it will be going to the different AMP. So how it is going to different AMP, I will tell you the next session. Hi everyone, welcome to Nick IT Academy. In this series, we are learning Teradata completely. In our today's session, we are going to learn about unique primary index. What is UPI? How it can be created? What is secondary index? Unique secondary index, non-unique secondary index. What is partitioned primary index? And what is skewness? what is 1 AMP operation, 2 AMP operations, and Teradata data protection methods. And we are going to learn about Teradata data protection methods. We do have many concepts in data protection methods, like we have node level, AMP level, and disk level protections. We have RAID concept, fallback concepts, and click and lock concepts. So that we are going to learn about. So keep watching the session without skipping it. If you haven't subscribed our channel, please subscribe the channel and click on the bell icon so that you'll be getting all the notifications. Thank you. Let us start our session. Like primary index is nothing but whenever you are creating a table, if you mention, so it will accept the primary index. If you don't mention, it will take first column as the primary index. But so after the Teradata 13, so we have that like no PA concept. So nowadays in real time, if you don't mention in our real time, so if you are not mentioning a primary index, so this table will be taken as no primary index table, no PA. So it's based on the company, how they are defining it, the admin level. If you don't mention, the first column will be taken as primary index. Okay, that is what a normal scenario, default scenario. So even you can go for 2 or 3 columns for the indexing, and up to 64 columns you can go for the indexing. So how the indexing will be working? So if you are creating index, primary index or unique primary index, it will be a 1 AMP operation. I told in the morning, right? So 1 AMP operation, how it will be working. So you assume that this is but the record. Okay, record from the table, that client machine we are getting from application, or from the client we are passing it record. The ID column is like 2, 32, 67, 12, something. Some ID columns we are getting from the client, from outer world to Teradata. Then how it will be processed, right? So it's based on the indexing, like either it's a UPI or PI. It will create, the Teradata will create hash algorithm. Okay, the parsing engine will create the hash algorithm first. Okay, based on the primary index. So hash value for each and every record, the Teradata will create one hash value. So say for example, for this particular record, it is creating a hash value called 646. Okay, it will be maintained in one table called hash map. Okay, hash map table. So it will have the hash value, and each and every record it will have the hash value, and based on the hash value, it will have which AMP it is available. Okay, that particular record, which AMP. So based on the value, so if it is a unique primary index or primary index, it will have different AMP, right? So it will assign different AMP. This is what we will have. So if all the records are unique, then eventually it will be distributed, all the AMP. Okay. If you are getting duplicate value on the column, then one single AMP will have more value. Why? Because the hash value will be same for same record. Okay. So if I'm getting again 32, the hash value will be generated like 646 only. Same hash value will be generated. So if it is generating same hash value, then it will be assigned to the same AMP. It will go to the same AMP now. Okay, so that is why if you are getting more duplicate value on the column, so one single AMP will be getting skewed. So this is what we will say, like AMP has been skewed. Okay, so it should not be. That is why we are going for combination of columns. If you are going for combinations of column like primary index or unique primary index, so that column will not have more duplicate value, right? So that is why we can choose a primary index to avoid the skewness. This is what the algorithm will be maintained. So for example,
But
we are
hash algorithm and all will be taking care for Teradata only.
Teradata. We are not going to take care. So just we are creating. So our aim is to create the indexing. That's all. Okay. So finally, we have to tell them like if you are all the column mentioning, right? After that, you have to mention, close this bracket. Okay. Here we are opening the bracket, right? So close this bracket here, and then tell like which column is primary index. Primary index of country code, center, local ID. So country code is the first column, center, local ID is the some other columns. Okay, some other columns will be there in the so second column. We have a column, so we have to mention in this way. Then Teradata will create one hash value. It's like a number. It will create one hash value. Then based on the hash value, it will assign a AMP. This is like, so either primary index or unique primary index, it will be a one AMP operation. Why? Because it will go to one single AMP only. So retrieving as well as storing the data, it will go for one AMP operations. So here, if you are creating a table, while creating itself, you have to tell like either it's a primary index or unique primary index. If you are mentioning like unique primary index, that particular column will not accept duplicate value. It's like a primary key. Okay. So normally in Teradata, we will not create a table like primary key. So we will create like unique primary index. Got it? If you are mentioning a column as unique primary index, that particular column will not accept any duplicate value. So normally unique primary index definitely will not have any duplicate record. So all the AMP will have eventually distributed. So hashing algorithm will be created for each and every record. So based on the retrieval as well as storing, it will go to the particular AMP, it will store the data. So this is what it will have a unique primary index, okay? So this is what I have explained, unique primary index, how the data will be. If it is, if you are not selecting the primary index correctly, then one AMP will have more data. Okay, one particular AMP will have more data. Then this, we will call it as this has been skewed. Okay, to avoid that, we have to choose correct index. Okay, skewness. It is not distributed.
Problem will be like while retrieving the data, it will
Yeah,
take
retrieving as well as storing the data. It will go to one particular AMP. Okay, sometimes the Teradata admin team, they will send a mail like this table has been highly skewed. Look into it. Okay, then we have to check for so select star from the table. Okay, we have to mention like so select star from the table, right? It will show you that create table structure. Then you have to check which column we have chosen that primary index. Then go to the table. You check for that particular column. We do have duplicate record or not. So how many duplicate record we have? You check the combination of column or the single column. So you decide that okay, it should not be a primary index. Then you create a backup of the table and create another table with some other column as primary index. Okay, you change that primary index. Again, store the data from that table to this table. So that is the way you can avoid that skewness. It's very rare scenario after creating the table, but by creating the table itself, we have to check the tables and all, the initial stage itself, the record and all. Based on that, we have to choose the primary index. Okay. Then secondary index. So you have created one table with primary index. Okay, you have one table with primary index, but you are querying the table with a different column. You are querying that column with a different column. Okay, so you take this sheet. For example, you have the customer table. Assume that I have the customer table. You are having the customer ID and customer name. Like another column is called mobile number. Okay, mobile number. Then you have something like city column. Then date of birth. Okay, this is what column I have. So you are fetching the data based on the customer ID. So that is what you have given that primary index. Sometimes you will be fetching the data based on the mobile number also. Select star from the table where mobile number equal to this way. You are frequently accessing another column, not this column. Okay. So either this column or this column you will be accessing it. So this column you have access, you have created as primary index. You cannot create one more column as primary index, right? You cannot create one more column as primary index. So if you want to create, so this will be a unique primary index. You assume that it will be a USI, unique primary index. Okay. Then you have to create one more column as indexing column. Separately you have to create. Why? Because you are separately querying that column multiple times, single column. So for this column, you cannot create again indexing. Like primary index, you cannot create. If the table contains already index, this column will be a secondary index. If you are creating this column, it will become a secondary index. Secondary index is nothing but you are fetching the column. It is an alternate path, okay, for the data retrieval as well as data storage. Got it? Instead of going for this column, you are going for a different column. Then how it will be maintained in this database, right? This is two AMP operation. We will call it as two AMP operations. So normally the data will be stored based on the unique primary index only or primary index only. In the AMP, it will distribute the data based on the primary index only. For example, here I have ID, some ID columns. So based on this ID column, it will distribute the data in the AMP. So different AMP, it will distribute. But this is like something like mobile number. Some mobile number you have. So based on the mobile number, you are fetching the data. So this is an alternate access path. So you are fetching the data in different way. So how the Teradata will maintain? So so if you are going for secondary index, okay, either it's a unique secondary index or non-unique secondary index. If it is a unique secondary index, this is also a unique column. Okay, it will not accept any duplicate. So if you are going for some non-unique secondary index, then it may have duplicate value. First, we will go with unique secondary index, how the unique secondary index will be maintained. So if you are going for unique secondary index, how the data will be. So first of all, this is the algorithm, okay? You take it like select star from customer where mobile number equal to some number. Instead of customer, you take it like mobile number, something secondary index column we are going for. This is not actual column, this is secondary index column we are going. So hashing algorithm will create on hash algorithm. This is since it is the secondary index column, how it will be hash map. The secondary index, a subtable will be created. A subtable will be created in all the AMP. All the AMP, a subtable will be created. And also, remember this in Teradata, whenever you are creating the table, right? Whenever you are creating the table, like create table, table name, the structure will be maintained in all the AMP. You remember this. Whenever you are creating a table, it will not have one structure. If I have 4 AMP, right? 4 AMP, 4 AMPs will have the same structure of the table. Okay, this also will have the structure of the table. This also will have the structure of the table. This also will have structure of the table. This also will have the structure of the table. So it will have the ID called 2. This will have ID called 3. This will have ID called some 4 or 5 something. Okay. So if I have 4 record, the same structure will be maintained in all the tables, all the AMP, but it will have one record. Whenever you are creating an table, right, the structure will be created on all the table, all the AMP. Okay. The data will be saved based on that record which we are passing it. The same way, if you are creating a secondary index, okay, secondary index, a subtable will be created on all the AMP, okay. Teradata will create a subtable in all the AMP.
Okay.
So all the AMP it will create. So for example, if you are having like a mobile number equal to 998, something you are having, then hash value will be created for that particular row. Then this is like hash map. This hash map will have where is that subtable resides. Okay. It will have the hash bucket number 602 and AMP number and base row value. So base row value is nothing but it's based on the primary index value. So the record will be stored in the database based on the primary index, right?
Yes.
But this is the alternate path we are querying the table. So the record will be saved in the AMP based on the index, the primary index only. But this is an alternate path. So for example, this will be AMP number 1, 2, 3 or something. So based on this, the another path, right? Another path, it will have where the base row has been stored. It will, the hash map will have, remember this, okay, carefully listen. The hash map will have, where is that hash bucket? Hash bucket number is 602, okay. Then AMP number 2 is the subtable, where the subtable will be maintained. It will be AMP number 2. Where is that base row? It's 778. It will go to this particular the AMP number 2. It will check for the subtable. So each and every AMP will have the subtable, right? So this AMP will have the subtable called hash value 602 and AMP number 4. It will tell you like the base record is present in the AMP number 4.
Like it that hash bucket number will give not actually the where the record is located in which AMP. It will give
the AMP number. Subtable information. Subtable information. This subtable will give you that where that base row located.
Base actual record located.
Yeah. So it will give you AMP number 4 and then base row ID is 778. So the Teradata will go to this particular AMP number 4. it will check for the row ID 778. It will pick the data and then it will give you that result. Okay. Okay. So for this 998, this is what the record it will give you. So this is like 2 amp operation, not only 1 amp. It's amp number 2 also involved.
With only primary index, that is a 1 amp, and with the secondary index, it will be a 2 amp operation.
2 amp operation. Okay. For example, if you are going for unique primary, unique secondary index, this is the operation. If you are having any duplicate record, okay, there is no other row will be created on the amp number 2. For example, amp number row, this will not create another row. It will say like, so based on the, for example, you are having the same record, 988 here. It is like a duplicate, right? Duplicate, correct?
Yes.
So for these two record, for those, this is like a non-unique secondary index, correct? Non-unique secondary index. For the two record, it will have the same hash value. The row ID will be different, 778 and different value. The row number.
Okay.
So, but the same record, the subtable will have that 778 comma the another row number. So, for example, 640. It will have that ID, then it will go to that particular ID, and then it will pick the record. It will not create two record for the non-unique secondary index. Only one record will be created on the subtable. Got it? Okay. This is also a second. This is also 2 amp operations. So this is what it will be explained here. If you go through this, then you can able to get it clearly. Okay. This is like something like we will get some duplicate record. So here, name column we are fetching it, right? Select star from customer where name equal to Adams. Might be Adams will have two names. See here, Adams here also, right? Adams. So this is secondary index. Customer is the unique primary index. The name is the secondary index. Adams is 2 numbers, but the row ID is 222 and 115, right? Okay. The subtable will have that 222 and 115 on the same amp.
Yes.
Okay, same amp. Okay. Based on that, it will pick the record. Okay. 5672, 5671. It will go here and then it will check where is that row ID. It will go to this particular row ID, 222 and 115. It will pick that particular record from the amp number, some different amp, and then it will pick the record. So this is what it will go for the non-unique secondary index. Got it? Okay. Primary index, unique primary index, secondary index, that is non-unique secondary index, and unique secondary index. So this is what we will create. The join index concept I will tell you after some time. Then next one is like partition primary index. Okay. This is another index. On the same app, we'll go for partition. Okay. We are distributing the data, right, on the same app. Okay. While distributing the data, we are partitioning it. So partition primary index is the distribution of row based on the different partitions for the faster retrieval. So where we will create the primary partition index, right? This one, PPI. For example, you have the transaction date. Okay, some date column, order date, some transaction date. On that column, we will create PPI.
Oh, this is also while creating the table only we have to decide like that.
Yeah, definitely. So while creating the table, we have to mention that PPI column.
Primary. What will be the syntax then?
So here we will mention. Okay. So primary index order number. Primary index is order number only. Partition by range. We are creating say order date between this date to this date. Each interval is 7 days. Normally we'll go for 1 day. So each day will be 1 day. So this is for 1 year they went for, right? 1 year. So 1st January to 31st December, right? So each partition will have 7 days of data. Normally we'll go for 1 day. So 1 day once we are creating it, assume that. Okay. So order number, primary index is order number only, but order date is partition. For example, order date. So we are having like there we have created like 7 days, right? 7 days or 1 month. This is like 1 month. See now, we are fetching the data based on this. So we have the 4 amp here. Okay, 4 amp here. So it's based on the UPI, right? The order number. The order number, it will be distributed, correct? So 1 is here, 2 is here, 3 is here, 4 is here, like 5, 6, 7, 8 distributed based on the UPI. But we are creating one more column, order date. It's a partition. So if you don't create partition, if you are fetching the data, so within this, some order date you are going for. For example, you are going for select star from the table where order date equal to this date. Since it is not a primary index, Teradata will confuse that where the data has been reside, right? So this is green color is January and yellow color is February.
Okay.
So it is not eventually distributed. But if you are creating partitioned primary index, then within the AMP itself, it will partition. So the above will be January, the below will be February. Normally, we will create like transaction date, order date. Each one day will be on one partition.
Okay.
So within the AMP, we will go for the partition. It will distribute the data based on the primary index column only. But within the AMP, we are going for, anyhow, this is also one table, right? As I told, every AMP will have separate table list.
Yes.
Again, this table will have some data. Within this table, we are going for partition. So this is what partitioned primary index, PPI column. Okay. So PPI column, this is what the syntax you have to follow. If you check some other table syntaxes in real time, go and check how to check it, right? So you will have some column like a transaction table or some table. Like you can check like this. Okay. If you are going for show table, okay, show table, table name, it will give you that something like order table, for example, order table.
Okay.
It will give you that normally here we have to mention like a DB name. So which DB is present? DB name dot table name, you will make it. In our database, we have some database DB1, DB2, something. We have something like production, okay, P underscore tables, production table. We have the table name. So you can show in this way, or you can go for show select star from, the table name. If you are mentioning this also, this will give you the structure of the table, how it has been created. There you can check the create table structure, how it has been created. Okay, you can check how they have created. They have mentioned in this way, primary index and partition by something. This is a PPI column. So definitely the large table, right? Transaction table and all, they will create PPA. Transaction table, sales table, some invoice table, like fact table. You know the fact table, right? The fact table will have, they will create like a partition primary index. So indexing the secondary index, what is the disadvantage of secondary index? Again, it will create the subtable, right? So that is a disadvantage. And also if you are going for some fallback operations, when we are creating the fallback table, so it will maintain the data in the different AMP, then it is a overhead to the subtable information. Okay. So PPI definitely needs additional space, like over 2 KB per row. So why? Because it is again this partitioning, right? This information is creating, like each and every AMP is creating. So each and every row, it is like another 2 KB of data. Then it is again the space wise, it is overhead. So that is what the indexing concept.
Okay.
Anyhow, we will create this concept. You will see again this concept while seeing that create table structure.
Okay.
So now we will see that something like the data protection. What is the data protection? All those. Then we will see like the RAID concept. All those, right? The data protection is nothing but how are we going to protect our data? Okay, in the fault tolerance, something goes wrong. Okay, something goes wrong in our Teradata environment. How are we going to retrieve the data? Okay, so it has 5 different level. Either can be a disk failure, okay, the storage failure, or it can be a node failure. The entire node can be failure, or it can be a AMP failure. So one AMP is failed, then how to retrieve that particular AMP data, right? So the data has been stored in one particular AMP, so you cannot retrieve it if the AMP is failure. Or transaction level, if you are doing some operations, some select operations or insert operation, in between something happened, some data only will be inserted, right? So how to retrieve the other data, everything we are going to see like transaction level and object level. Object level is nothing but the table level. So we have different method. So first method is called RAID method. RAID, okay? It's a disk level protection, or disk level data protection. RAID is nothing but redundant array of independent disk. Redundant array of independent disk. So we have different, so RAID is a concept actually. It is like a concept. Teradata have used RAID 1 and 5. 1 and 5. Yeah.
Okay.
So RAID 1, RAID 2, RAID 3, we have different RAID concept for the database environment. So Teradata, they have taken RAID 1 and RAID 5, okay, for the disk failure. So RAID 1 is nothing but disk mirroring. Okay, so we have the disk mirroring concept. We have the AMP and then disk, right? The virtual disk we have.
Yes.
In Teradata, it will have the disk mirroring. So we will mirror that. Okay. So something like EMC square logic we will use. It's a disk mirroring is a RAID 1 concept. Okay. RAID 5. RAID 5 is nothing but some other concept. It's a data parity protection. So wherever you have something like array of data, okay, it's nothing but whenever you are going for you have the data warehouse environment, right? You have the data warehouse environment. Some data only we will frequently query that data, right? You will not query like 5 years of data or 10 years of data frequently. You will query, but not frequently. So whenever you are having you are not querying the data, that will be maintained in separate, so separate disk. Okay, you are not going to query that data. But whatever you are querying frequently, that will be mirrored out. Okay, so you are, for example, you have IRCTC. Last 4 months only you will be frequently querying, right? Last 1 year.
Yes.
You will not query like last 10 years of data.
Yeah.
That 10 years of data will be maintained in one disk. Okay, we will not go for something like mirroring. But whatever we are frequently querying, that will be mirrored out. Okay, last 5 years only we will mirror out. So that concept will be RAID 5. But RAID 1 is like all the data will be mirrored out. Mirroring. For example, RAID level. So mirroring and do duplexing. The data will be duplicated in the second disk. How it will be? For example, this is what you assume that RAID 1, okay? Disk duplexing. So you have something like a disk, right? So this is like a disk. We are the disk. Disk 1, disk 2, disk 3, all those, right? We are the disk. So this is like mirroring. We have one more disk. Okay. Disk array controller, DAC is nothing but disk array controller, will have that information like if this disk failure, okay, if the actual disk failure, it will tell like go and take it in the mirror disk. This is actually the mirror disk. Okay. So mirror disk, the data will be stored in the mirror disk. You remember, if you are going for mirroring it, you have to record for 1 TB of data, you need to have 2 TB of disk. Data is fully replicated on the mirror disk. Whatever the data is available here, it will be mirrored out. It will be mirrored. Okay, we are not going to do any replication or we are not going to take backup. It will automatically DAC will take that whatever the data it's storing here, right? The same way parallelly it will store here also. If you delete record here, it will automatically delete here also. But you have 100 TB of disk, then 200 TB of disk record. 100 TB of data you have. If you are going for RAID 1 concept, you need to have 200 TB of hard disk.
Yeah.
Got it? Double the storage. Okay. So this is what I explained. Like RAID 1 is nothing but the mirroring. So D1, D2. So disk 1, you will have disk 1 mirror. Disk 2 will be mirrored. Disk 3 will be mirrored. So this will be disk 1, complete disk 1 and disk 0 and disk 1. Within the disk, you will have like a mirroring. Okay. So this will be a mirroring one. This is also. So either one disk controller will be there or two disk controller will be there. Duplexing. So it's more advantage. So two disk controller will be there to maintain the separate way. If one path will get failure, the other path will take it like data. This is for the RAID concept. Okay. RAID 5 is nothing but something like parity. Okay. Parity. So there it is maintaining like disk 1 and disk 1, disk 2, disk 3 is same like this way, right? But how it will be maintained here, RAID 5, okay, stripping with parity. So how it will be data divided into even number of blocks, okay, even number of blocks with additional parity block. So where it will have been. So for example, here I have A1, B1 and C1. For the A1, you will have the block in different way. Here you have the parity block, okay. This will have all the A data, the parity data, wherever the A
Oh,
is present. Then C will have C1, C2, C3 will have here something different disk, you will have the C data. So D is not available here, right? So D1, D2, D3 for parity blocks, it will be maintained here. Okay. So this is what you can reduce something like data storage. If any one of the drive has been failure, data recovered with remaining blocks, the parity informations. So this is what you can take it like RAID 5 concept. So they will go for RAID 1 normally.
then all D1, D2, D3 data will be stored in parity
Yeah,
disk.
parity disk, yes. Like mirror. Okay, so you have the disk 1, mirror disk you will have always. This is like logical unit, one logical unit. LUN0 is nothing but one logical unit. One logical unit will have all the blocks and you will have a mirror block also. This is called RAID concept. Disk level failure, you have RAID. So disk level failure, you have RAID concept. Node level, we have hot standby. So AMP level, you have fallback. Okay. What is that fallback? For example, you have 4 amp. Assume that you have 4 amp. AMP 0,
Okay.
AMP 1, AMP 2, AMP 3. If 1 amp is failure, then the data has been stored in this amp is you cannot retrieve, right? We are not going to
Yes.
store the data in the AMP, but the structure will be maintained here. It will access through this AMP only. The data we are fetching through AMP only.
Yes.
If 1 amp is failure, then it will be difficult to retrieve the data. For that, whenever you are creating a table, we will create a table with fallback. So in our environment, whenever we are creating a table, even though it is default, if you are not mentioning, it will be created as fallback table only.
Okay.
So by default, sometimes you can find like a table with normally it's a no fallback table, right? By default. But in real time, in our environment, we have fallback table. Fallback table. So what is that fallback table? The mirroring happened on the AMP level. So AMP level, the mirroring will happen. So for example, the record 62 is coming here, right? The same 62 will be maintained in some other AMP also in the mirror, in the fallback rows. Okay, 62 is here. The 62 are on the fallback.
Oh,
If this has been failed, this AMP has been failed. So 62, 8 and 27 will be on different AMP. 62 will be on this AMP, right? 8 will be on this
yes.
AMP. 27 will be on this AMP. Got it?
Oh, oh,
So yes, one AMP has been failure. The data can be retrieved on all other AMP. This is called a fallback. Whenever you are creating a table, you should mention that by default it will be no fallback. But if you want to create a fallback, again it's overhead to the storage. But the retrieval is very easy. So whenever you are
oh,
having some critical data, right, some
yes.
sensitive informations, for that we will create like fallback. Next one is like node level. Node level we will collect like click. So I told you, right, the node will have something like node 1, node 2, node 3. It's a cluster, like horizontal way of storing the data, correct? So one SMP will have different node. So SMP 00001 to 009. SMP 001, something like 1 to 10, something like 11, 12. Okay. So you have something like different numbers you have. So
Yes.
SMP, this is one SMP. One SMP is having some node number 0, 1, 2, 3 up to 9 node we have. So all the node will be created by based on the sharing the disk. Okay. For example, if the node is disk controller, it is storing here. The same will be connected to the another disk also, disk A. This can be a mirroring option also. Okay. Disk A will be here also. Click. This is one click. Okay. If any one of the node has been failure. Okay. If one of the node has been failure, how the data will be. For example, This is node 1. Okay, node 2, node 3, node 4. Okay,
Mhm.
always you'll have one hot standby node. Hot standby node. Whatever the activity which has been taken care by this node 1 will be transferred to hot standby node. So whatever the activity has been taken care by this node, right? So all the activity will be given to the node, the hot standby node. This will become node 1 now. After that, we will rectify this one and then we will make this as a hot standby node. Once you are bringing up this particular node, this will act as a hot standby. It will not act as a node 1 again. Okay. It will act as a hot standby node. If any of the node is failure, whatever that it will be processed, the database is processing, it will be transferred to this particular node, then it will become a hot standby node. So this is what it will be maintained, the click concept. In case of node failure, so it will be transferred to other node, whatever the handled by this disk and everything. So there won't be any failure. Okay. The locking system I will tell you after some time. So how the locking will be, while we are creating the table, I will tell you that locking. Okay, locking alone I will tell you. Here we have seen that the disk level it's called read, amp level it is called fallback, the node level we will call it as click. Okay, technology. This is what the data protection in the Teradata. Got it? Sometimes in the interview they might be asking this concept. So consider this table. It's a simple create table, and we have all the columns like integer, varchar, and date columns. So I'm going to create this table. I didn't mention here any indexing. So I'm going to create this table. So if I'm directly going to this create table, then it will be going to the DBC. DBC, you will not have access. So normally you have to mention the database. So which database you are going to create a table. So here in DBC I told right, it's a database computer. So in DBC we do have a lot of databases. So any one of the database you have to mention the table name. Okay. So I'm going to mention the database name as retail. Retail dot the table name. So table name I'm mentioning like employee 28. So I'm going to create the table in the database name called retail. If you don't mention the database name right, it will not be able to create. So it is showing like below, it will show you whether the table has been created or not. So it has been created with the 0 rows. So if you want to check after creating the table, you want to check whether the table has been created or how it will be, you can use something like select star from the table name. So you cannot directly use it. You have to use in this way. Select star from table name. It will not. It will show you the table, but it will not have any record. Okay. So it will show you like select completed 0 rows returned. So you want to see the structure of the table, how that has been created. As I told yesterday, so you can make like show select star from. So if you are making show select star from, it will show you that this is what it will show you that the table. Okay. So since here we have created a simple table, create table name. So by default, it is creating a set table. Set table in the sense it will not allow full row duplicate. Set table is different. Unique primary index is different. Unique primary index, that particular column alone, it will not allow duplicate. But set table, all the columns, it will check all the columns. Same record should not be repeated. So by default, it will create a set table. It is creating a no fallback. Yesterday we have seen right, no fallback. And before journal, after journal, I will tell you what is that journal concept after some time. Checksum. So checksum is nothing but it's a OS related stuff here, Teradata and OS related. So it will have always default. And see now the employee number, it is integer, all those. So here we have the first name column. It is a varchar. The varchar of 20 we have given. So it will take it like character set. Okay, so normally we have two types of character set. One is Latin and another one is Unicode. So either it will be created as Latin or Unicode. So normally if you are having like any metadata tables like DBC or some other tables, it will create like Unicode. Okay, it will not allow any junk values. If you are creating user table, it will create with the character set Latin. So I will show you some other tables like metadata table so that you can able to see the differences. So I'm going to use select star from dbc.tables. Okay, dbc.tables, it will give you all the table list, and then tables v is nothing but view. We are not going to directly hit on tables, we are going to hit on the tables v. Tables v is nothing but on top of dbc tables they would have created one view. These are all something like system table, right? System tables, I'm just opening it. Okay, the character set they haven't defined, right? So normally by default it will take character set as Unicode. For the user table it will take it like Latin. These are like metadata table. So this table has been created with so character set Unicode, right? So this is what it will have. So not case specific. That means this column, so case insensitive. If you are giving like varchar, right? So if you are giving like any case sensitive data, it will not, no issues. Even you can give anyway. So this is what table will be created. If you check here, the character set is two types of character set. One is Unicode, the other one is Latin. So after that, you will find the date format. Date format you have to give in this format only, and the case specific. It will show you not case specific. If you want to mention like case specific, then you have to remove this and you have to create it. So primary index it is taking like employee number. So always first column it will take it as an employee number as first column as primary index. Got it? So this is what create table. So either you can go for show select star from, or you can mention like show table show table name. Then it will be able to create it. So on top of this table, if you want to create any view, you can create it. Okay, something like create or replace, or you can go for directly replace. Create or replace view name. So view name is so whatever the database we are creating, like retail dot so employee 28 underscore v. I'm creating a view as select star from. Yeah, if you want to create different column, you can be able to create different columns. You can directly go for replace view. So here you are not having that create view access. So I'm going for replace view name. Whenever I'm inserting a data into the table, the view also will get updated automatically. Okay, so here you can go for show view name. So you can mention like show view. It will tell you that what is the base table you have used. So what is the base table you have used to create a view. So that is why you will go for the show view name. So if you are going for select star from the view, it will show you the table name as well as the view name also. Okay, if you are going for select star from the view name, okay, it will show you the table name as well as view name. So this is a way in real time also. If you want to check how the view has been created, what are the columns they have mentioned, all those you have to go for this way. The base table as well as the view will be showing you. So this is like a set table. It will not allow any duplicate record. It will not allow any duplicate record. So for example, if you want to insert some record into the table, insert into the table name. Okay, so you can go to the values. So you can mention the values. What are the values you want to have? For example, employee number. I'm going for employee number. So department ID, then first name. So I'm giving one first name, last name, comma, salary I'm giving. So I'm giving some salary here, and I'm giving date of birth. So date of birth you have to give the format like this way. So this is what you have to give the date format. So I cannot give the address like this way. You can address, close it, and execute it. So this line you can execute. One row inserted. If you go and check in the table, it is a set table, right? So select start from the table name. It will give you the result. it will give you the result. Okay, but if I'm going to if I'm trying to insert the same record, if I'm trying to insert the same record, it will not allow you. Why? Because it's a set table. It is a set table. The full row duplicate it will not allow. But since we have created the employee ID as the primary index, it will allow duplicate. If I'm going for this department ID 30, so it is not full row duplicate now. Since it is a primary index, it will allow now. If you have created the table as unique primary index, then it will not be allowed. So you can use it like this, and then you can see that 2 record is available. If you are checking the view also, you will have the 2 records automatically get updated, the view also. So this is what the set table. If you have created like multi-set table, then this record it will allow you. For example, this table, I'm going to create like multi-set table with multi-set table, and I'm going for employee 29. Assume that employee 29. If you are not mentioning anything, it by default create a set table, right? So here I'm going to use multi-set table. You have to explicitly mention that multi-set table. That execute. Table has been created. Now I'm trying to insert this record. So into this table called 29. So it will be inserted. So even 2 times I'm going to execute. So 3 times it will be executed. So it will allow you to enter into the table. If you are going for some performance issue, you will go for multi-set table only. Why? Because it will not always check for the duplicate record. Table and all you are creating, right? Work table and that stage table and work table. Stage table and work table. These are like intermediate tables. So normally this is what the table will be in the real time. First, it will go to the stage table. So from any outer world to Teradata, we will load it into the stage table, like incremental data. So from stage to work, we will load some intermediate calculation we will do. After that, from work table to final table. So you can have multiple work tables also, like one work table, then second work table. You can do lot of transformation logic between the work tables, and you can load it into the final table. So final table will be a incremental load. So already data will be there in the final table. You are going to insert or update based on that. But work table and stage table is a truncate and load, like delete and load. So you will already delete the record and load it. So delete and load we will use. So this is also work table also, delete and load we will use. So it's again it's based on scenario. If you are facing some issues, you are going for the work table based on some insert into select you are making. Insert into select. Some you are getting some huge volume of record. There if you do not want to check duplicate, then you can go for the multi-set table. It will not go for the duplicate check. Then the performance will be the performance will be faster when compared to set table. Set table means always it will check for the duplicate, right? Whenever you are inserting a record, one record if you are going to insert, it will Teradata will check that whether this record is present in any of them. It will check for the duplicate. So that is why it will take a lot of time. Instead of that, we will go for multi-set table. Normally multi-set table. But some scenario, if you are expecting like you should not allow full row duplicate, there you can go for set table. In our practical environment, we are using most of the cases are multi-set table only. And creating a set table will not allow any duplicate. Multi-set table will allow duplicate. So unique primary index. So I'm going to set table, right? Already set table, it will not allow duplicate record, but full row duplicate. But unique primary index is nothing but this column alone will not allow duplicate. The other columns it will allow duplicate. Okay. So if you are mentioning like all the columns you mention it, finally you mention like unique primary index of employee number. It will not allow duplicate. This column will not allow duplicate. So I'm going to create this table. So I can go for even multi-set table also. Okay. So that column will not allow any duplicate. Okay. So we should not go for directly. You have to use the table database name. So database name, and then you have to run it. So table has been created. Now if I'm going to insert the record, even it will not allow duplicate on the particular column. So maybe 30. I'm going to insert the record same record I'm going to insert it, duplicate unique primary key value. That is what we will be getting. So if you are changing this, it will allow. Now it will allow. If you are changing other columns, for example, if you are changing other columns, last time you have changed the department ID, this time it will not allow. So why? Because this column alone we have created as unique primary index. Okay, so if it is a set table or multi-set table, so it will allow. But here it is a unique primary index on this particular column, so it will not allow you to insert the duplicate record. So this is UPI column. So this column will not allow any. So it's completely on one-AMP operations. Okay. So non-unique primary index, if you are not mentioning anything, it will automatically take non-unique primary index. Set table with the unique primary index, that is what we have created now. Set table with the primary index, set table with the unique secondary index. So if you are going for secondary index, right? Unique secondary index, primary index and unique secondary index. So unique secondary index will not allow duplicate on the secondary index column, this column, unique primary index and unique secondary index. Okay, both. So I'm removing this. I'm just creating like primary index and the unique secondary index. So whatever the way you want to have, you can create it. So it has been created. Now this column will not allow duplicate. This department, one person should be there in one department only. So only one person will be allowed for one department. So I have entered. Then I'm going for some other person, but of the same department. It will not allow. Secondary index uniqueness violation. This is what you will be getting. Then you have to check what is that secondary index it has been. You have to go for like select star from this show table name. You can mention it, and then you can check how it has been created. Okay. So you can assume that okay, primary index of employee number unique. So if you are going for secondary index, no need to mention like secondary index and all. If you are mentioning like indexing, primary index or indexing, it will take it like first index will be a primary index. The second index it will automatically take it as secondary index, unique secondary index. So if you want to explicitly mention unique, you have to mention like unique unique. So here the table has been created with multiple primary index. Okay, can I create multiple primary index? Yes, you can create multiple primary index. Like I'm going to create with multiple primary index. So this way it will reduce the skewness. The combination of these column, it will go for the hash value. Okay, it is used to create the hash value. Then it will reduce the skewness. So this is multi-column primary index. Here you can go for unique primary index also. These three combination, it will not allow duplicate. Unique primary index, okay. I'm going for 34 now. This combination, it will not allow duplicate. See here, 34, I'm creating it. I'm giving some value now. This will be allowed, okay. Again, so since it is a unique primary index, I'm changing some other number. Will it allow? The employee ID, I have changed a different number. It will allow. So when it will not be allowed?
Same primary number. Same number will not be allowed.
Yeah. See here, I'm going to create this table. It will allow now. But if you are going for same employee number, department number, and salary, it will not allow. So different location I'm going for. So it will not allow. Why? Because the same employee number, department number, salary I'm using. Instead of this salary, I'm going for different salary. It will allow now. So this is what combination of some columns for the primary index. Either it is a primary index or unique primary index. You can go for anything. A fallback table, as I told, so we are not going to see any differences in the fallback or no fallback. By default, the database will take it like.
By default, it will be taken as fallback.
No fallback. By default, should be no fallback.
Oh.
Okay. See here, I'm showing you by default It will be a no fallback table. If you want to mention, then you have to mention like after mentioning the table name, comma, fallback, you have to mention it. Then it will be created. Okay, so here you have to mention, so fallback. Okay, this way you have to mention. Then it will be created. For example, I'm creating like something like 40. I'm creating a table with fallback table. It will be created. So select star from 40. It is a fallback table now. It is a fallback table now. So this is the way you can create a fallback, no fallback table. Creating a table with no fallback, by default it will go for no fallback, or you can mention like no fallback. Before journal, after journal. Journaling concept I will tell you after some time, okay? After journal, dual journal, columnar table. So this one, creating a unique secondary index after creating a table. So if the table contains a record, even you can change the unique secondary index, or you can create the unique secondary index after creating a table. So making an exact, I will show you. Okay, after creating a table, if you want to make, if you want to change the primary index from one column to other column, how to do that? I'll tell you. Okay, exact copy of the table with the data you have to mention this way. Create table, table name, create table, table name as another table name with the data. If you are going for the table name, you can mention simply a table name, or if you are going for something like select star from, then you have to mention like, so if you want to create an exact copy of the existing table, you have something like a backup table we are creating, right? So we can create like backup table like this. Okay, so I'm going to create one table. So I will check whether the record is present. Yes, record is present. I'm going to create one more table, backup table for this table, exact copy of this table. Okay, so you have to mention create table, table name underscore bkp. I'm creating as, you can mention the table name or the select also. So you can mention the table name or select also as table name with the data. You have to mention in this way with the data. So if you want to have only structure, then no need to mention that. You can mention like with no data. You can mention like with data or with no data. So these two are same. If you are making select star from, you have to make it like bracket. So this one I'm creating it right now. Create table completed. This also will create the same table. Different name I have given. If you go and check this backup table, the record is present now. So this is a backup table. So if you do not want like data, you do not want the data, you have to mention like with no data. Only structure of the table will be created. So table has been created, right? So if you go and check, this table will have only the structure of the table. After that, you can insert into table name something. You can mention it. So you want the primary index also to be copied. Then you have to mention with the data, comma primary index of. So you have to mention like primary index, right? Otherwise, the primary index will not be copied. Primary index of that column you have to mention it. Which column you want to make it like primary index. So for example, this table, right? So select star from backup, right? So primary index. So since it is only first column, it will be automatically taken. But if you are mentioning like different primary index, right? It will not be taken. 34 backup. I'm creating it with the data. Okay, data. We'll check whether the primary index is copied or not. Okay. Show table, table name. It will show you that. So primary index didn't copy it. Here we have the show table. We have how many columns are there in the primary index? 3 columns. We have created like with the data. Since we haven't mentioned that primary index, it will create like only one column as primary index. If you want to copy it, then you have to mention like this way. So backup one I'm creating, okay, with the data, with the primary index of
3 columns. So we have
the column you have to mention, okay. Primary index of those 3 columns you have to mention. These 3 columns you have to mention it. Otherwise, it will not be created like So whenever you are
Yes.
creating a table, so you have to mention that primary index also. Now if you go and
Okay.
check this table, backup one, okay. So underscore backup one show table, it will have that primary index also. So, the backup table also will have the primary index. This is what you have to create it with the data and primary index. Only to mention
Oh,
make commander, you have to directly mention like with data space primary index of which column you want to have. So you can create in this way. If you don't mention, the first column will be taken as primary index while creating the backup table. So this is like create table, select star from we have used, right? Instead of table name directly, we are using just select star from the table name. Okay, with the data. Specific column if you want to have, then you can mention like select the column names with the data. If you want to create table with statistics, you have to mention with the data and the stats. So you'll do some collect stats, right? If you want to create a table,
mm-hmm.
so you are selecting some record from other table. So you want to copy the stats also with the primary index. So you have to mention with the data and you have to mention in that way. Stats also will be collected. Statistics means it is after loading the data on the table we will create statistics. So now we will create one table with primary index and then we will try to change it. We are creating a table with primary index of employee number. Okay. So first we are creating the table as primary index of employee number this way. Then I'm loading the data. Before loading the data, if you want to change it, you can change it. For example, first of all, I have created the table with primary index of employee number, right? After that, I want to modify it. So I can mention like alter table, table name. Table name is this is the table name. Okay, you have to use modify. Okay, modify primary index of. If it is simply primary index, you can mention like primary index of instead of employee number, I'm going for employee number and department number. Right, employee number, comma, department number I'm going for. So this one I'm executing it. The table has been modified now. Okay. If you check now, show table name. Since we don't have any data in the table, it has been modified, right? So table. So it will be available like you check now. So it has been changed. But we have created a table. Okay, so I'm going to drop this table, recreate. You have created a table and loaded some data, drop table, table name. I'm going to create again the same table with only one column as primary index, and I'm going to load some record into the table. I'm going to load the record into the table, so with the primary index of one column, right? After that, I'm using the same alter statement. So with no data, we able to do it, but with the data, you cannot able to do it. We cannot do it. Okay. So this is what you will be having alter table name. If you want to do it, one thing is you drop the table and recreate it, or you create a backup table for this and truncate the table, entire table, delete all the record and then load it again. So we will do it now. So I'm going to create a backup for this table, or you can do one more thing. You can simply rename this table. So normally you will not drop the table, existing table. So rename table name to new table name like 50 underscore. Simply we are creating a table with backup. Rename table, old name to new name.
Mhm.
I just renamed. Okay, the table. Now I can create the table with primary index of two columns. Correct? The 50 has been renamed now. 50 will not be available. So I'm creating the table with two columns now. I have created table. This is what we will do in real time also. Then you have to bring back the record from backup table to normal table. Insert into this table. Okay. So you have to mention select star from the table name, right? So you can directly mention, no need to mention anything. Select star from underscore backup.
We rename the existing table and then we recreate the table and then we are trying to insert the
Yeah.
whole.
See here. Select. So instead of creating a backup table and then drop and recreate, I haven't dropped a table. So why? Because sometimes if you drop the table, the property also will get dropped. Table property will get dropped, right? That is why we have renamed it. This table structure will not anywhere change. Sometimes if you drop the table and recreate it, right? Some of the Unicode character or some character they have created, it will be changed to the default, the table and all. So to avoid that, we are going for this way, renaming it, and we are doing it to primary index. The same way, if you want to go for unique primary index, you have to mention modify unique primary index. So if the table doesn't have any record, so if you want to make it like unique primary index, you can mention like unique primary index. This one will not be, it will not do it now. Why? Because the table contains record. Okay, unique is not allowed. So you have to use delete from table name. So here in Teradata, so whatever that statement you are executing, it's auto commit. Okay, if you have deleted, that's all. After deleting it, you cannot retrieve it. So in Oracle, we have something like you can retrieve, right? DML statement, you can do the rollback. But in Teradata, we don't have any rollback. Okay, that is why we should be very careful on before deleting the record. So after deleting it, I have changed it unique primary index. Before that, we were getting some error. Now it is, we are getting like, okay, the table has been created, altered. So this is what you can go for primary index, set table, multi-set table, all those. The one thing is, if the table contains data, you cannot alter it, correct? So what we can do, two ways you can do. One thing is, you create one backup table for the existing table. Okay, so you create backup table. Here you have the table. It has some data also.
Yes.
It has some data
Okay.
already. Okay.
Okay.
Something like this will be a primary index now. But you want to add this column also primary index. So with the data you cannot modify. What you can do?
Okay.
You can create one backup table for this, right? You can create one backup table, and then you can truncate all the record from the table. You can delete table. So if the table doesn't have any record, then you can modify it, correct? Modify it and bring back again. Or you can drop the table. But if you are creating a backup table, right? Sometimes the table structure, okay, if you are dropping a table and then creating it, this table structure might be the Unicode or fallback or some other, they would have created something, it will get changed, the primary index will get changed. To avoid that, so if the table contains data, we are just renaming it. This table, we are just renaming it, okay? We are renaming it different way, we are renaming it, this table. So just we are renaming it, this one. We are renaming it this one. And then we are creating one table newly. Then we are bring back the record from here to here. Okay, so anyway, you can, the both way we will do, but renaming option only we will do. Why? Because we are not going to drop the table, right? The table will be maintained. While dropping it, if it is something happened while creating the backup table, some record is not moved correctly, then it will be a very big issue, correct? You have millions of record here. Okay, in this table, you have millions of record. You are creating a backup table. If it is not correctly created the backup table, what will happen? If you truncate the table, main table, if you truncate, the record will go off, right? So to avoid this kind of confusion, we are just renaming it and then creating the table structure with modified primary index, then inserting it by selecting the backup table record. So insert into table name, no need to mention anything, directly you can mention select start from that column name. Okay, no need to mention any bracket or with the data or something, no need to mention all that. Okay, so this is what you will go for the create table structure. We need to do, as you said, you are going to work in something like bteq script or something. We are having source table. This is source table. This is Teradata. You are bringing the data from this table to Teradata. So you are going to do lot of logic in multiple stages. Multiple stage. You are not applying all the logic into a single query. You are going to apply a lot of logic, and then you are bringing the record to this final table. These are like a stage table. This will be a stage table. Okay, this will be a stage table. This will be a work table. Table 1. Okay, work table 2. something like work table is nothing but some intermediate table. Normally you will have some intermediate table. So intermediate table you will have. You will bring the record from the source table to the stage table. Stage table always will be a delete and load. Why? Because you'll have all the data to the final table here, right? Up to yesterday data, it will be available here. No need to keep the record in the stage table or even any work table. Normally, stage table and work table are delete and load. We will delete the record in this table and then load it again. New record.
Okay.
For today, we will load it again, right? This was stage table. For example, just up to yesterday, you have loaded the data into the final table. Got it?
Mm-hmm. Okay.
Up to yesterday, you have taken the record into the final table. So you need to
Mm-hmm.
bring back today's record only. That is the delta load, correct? We will call it as
Okay.
delta, right? So delta record. That is whatever the data has been inserted or updated after this particular date. We will have some threshold date. From that date only we will fetch. For example, up yesterday 7 p.m. it has been loaded. Up to 7 a.m. it has been loaded. Okay, or 9 a.m. it has
Okay.
been loaded. Yesterday up to 9 a.m. loaded. So yesterday's 9 a.m. to today's 9 a.m. is one day data will be available here, right? It is not available. It is not loaded here. So we
Yes.
will take that one day data and then load it into the stage table.
Mm-hmm.
Do I need the yesterday's table, the data in the stage table? No, right? We
No.
have already
Yes.
loaded. So stage table, we will
Yeah.
delete the already record and then load it. Then stage
Okay.
to work table, we will do some transformation logic. We will do some transformation logic. From work table 1 to work table 2, we will do again something like join, subqueries. We will apply some
Okay.
logic and then we will load. Again, here to here,
Okay.
we will apply some logic. So
Okay.
we don't have any more record. Then we'll go for merge query, merge into
Mm-hmm.
target table. So you know that merge,
Mm-hmm.
right? Merge statement, merge query also,
Okay.
merge into this table. Why? Because why we are merging? If the record is already present here, we will update. If the record is not
Okay.
present, we will insert it. That is what we will do.
Okay.
So now always remember the stage table and work table will be delete and load. We will delete the record in the existing table and then load it. Why? Because this
And
will
we
have
will load
only
it.
one day record. This all the orange color represents one day. But it will have final
Oh,
table will have all the history of data. We are just
yes.
inserting or updating, right? We are not
Okay.
deleting it. Okay, that is why the stage table and work table will be. Stage table is
Okay.
landing area, might be your Oracle. So from Oracle to you are bringing the record into the Teradata, correct? So
Yes.
first you will bring the record from Oracle to Teradata in the stage table.
Mm-hmm.
This entire
Okay.
staging is under Teradata. Got it? This work table, stage table, and final table will be on the Teradata. So normally Teradata will be running on the parallelism, right?
Yes.
For analysis purpose, it will be good. So for analysis purpose, we are going to analyzing, right? For any banking domain or any domain, they will do a lot of analysis, like how the customer is performing, how the product is moving, okay, which region is performing well, which region is not performing well, how much we have collected for today's profit, loss, everything they will analyze it on the table.
All those details will be there in general normal rdbms also, right? But
Yeah, this is also
what is
rdbms only. Teradata also it's rdbms only, but it can handle huge volume of data. So this is
okay.
for the user. For example, you are having the banking, right? This will be your oltp system.
Yes.
OLTP is nothing but your online transactional processing. Also, if I
Okay.
am the user for my ICICI bank, I will go
Mm-hmm.
to www.icici.com and then I will do transfer, or I will purchase some. I'm going to recharge my phone. Then I will use my ICICI Bank mobile net banking, and then I'm using that amount and I'm doing the transaction. Right, everything will be saved in this database. So at
Then
one hour
when we are
once,
trying to
yeah, 1 hour once
okay.
we are loading the data from here to here for the analysis purpose. Due to Corona, how we are impacted last 4 days. Okay, we want to
Okay.
analyze it whether we have improved.
Okay.
Some business will get improved, some business will go very slow, right? I have different
Yes.
businesses. So what is the
Okay.
impact on our Corona effect? Something you want to analyze it. So you will analyze on this Teradata only. Most of the companies, if they are going for huge volume of data, they will analyze it through, on the Teradata only. Why? Because Teradata for analyzing it will be faster, running faster when compared to others. This Teradata is for analysis purpose, meant for business people, not for
Yes.
the end user. Sometimes we will get data from this Teradata also for the applications, but most of the Teradata, most of this OLAP system is meant for analysis purpose.
And
We will do analysis, okay? So that is why we are loading the data from here to here every 1 hour once or half an hour once.
when we are trying to uh, look for the history and all, there won't be they in general Oracle systems and all, we cannot able to access
Yeah,
those
yeah. Why?
details
Because
in.
it should not have more than 5 years or more than 1 year. It depends on the
Yeah.
company. Some company will have 5 years of data here. Some company will have only 1 year. So and
Okay.
also here, how can I find that the record has been changed last 1 hour inside or updated? We will something like commit timestamp.
Mhm.
Okay, so timestamp column will be there. Commit timestamp or created date or updated timestamp will be there. Commit
Okay.
timestamp or created date. Okay, or created timestamp, updated date.
Okay.
These columns is audit columns. Based on this
Oh,
column, we will bring that data into the Teradata. While we are loading the stage table, right? We will be making like select star from the table here, Oracle. Okay,
mhm.
where created date and timestamp is greater than or equal to 2 days half an hour. That sequence we will make it like. If it is half
Okay.
an hours, then 1 day it will be running on 48 times. 48 sequence will be running. Based on the sequence number, we will be passing the timestamp and then we will fetching the data from here to here.
Okay.
Whatever the half an hour it is getting inserted or updated here, it will be picked up.
Mhm.
We have three different types of space. One
Okay.
is permanent space. Sometimes they will be asking in interview also. One is permanent space, the spool space, and the temporary
Okay.
space. Temporary space. Permanent space is nothing but it is a physical space that the Teradata
Mhm.
objects will use that. Okay, something like tables, the views, and the databases. So users, it will be users on the space. It's the physical space it will be used. Like whenever you are creating a table, right? So it will be it will allocate some permanent space. So whenever you are creating a database, you have to give all these three spaces. If you are trying to
Mhm.
create a database, you have to give three spaces. One is permanent space, full space, and temporary space. Okay, permanent space is like so if you are having 1,000 terabytes of database, so how much you are going to allocate for permanent space? Okay, then full space, then the temporary space. So normally permanent space will have more spaces. And normally you have a database whenever you are creating, right? So database tables, users, all those it will take the views will take all the permanent spaces. Then you have the spool
Mhm.
space. Spool space is nothing but unused space. So unused permanent space is called spool. So you are running on query, on complex query you are running. You are running some rank, something like the rank. You are finding the rank, or you are doing some aggregations. Okay, you are doing some subqueries. All those you are running on BigQuery. You are running. It will take a lot of space, right? For example, you are going to run a rank function on one particular some millions of data, then it needs to compare with all the millions of data and it needs to do sorting. So it will take some space to do the sorting algorithm, or you are finding some distinct or rank or sorting or aggregation like minimum, maximum, sum. You are doing some aggregations. Then it will take a lot of space. That space will be taken from the unused space. So I told right. So if you have 1,000 terabyte of hard disk space, if you have allocated 500 GB for 500 TB for permanent space, the remaining something like 400 TB you are using for spool space. That 400 TB will be allocated in all the amp. We have some 10 amp or 12 amps or 24 amps. So how many amp we have? That whatever the space we have left out for the spool space, right? It will be allocated in all the amp. So whenever you are doing some intermediate calculations like subqueries, aggregations, joins you are doing, so that spool space will be used, the unused space. So we need to assign the upper limit of the unused space. That what is the spool space for each and every user. For example, you are one of the user for that particular database, right? For each and every user will have one spool space. For example, if I am the user for database, then each and every user while creating the user ID, they will allocate what is the maximum spool space they can use it. If they are allocating like five,
And explicitly, we have to like we have to mention it or what? How we will be
no, we are not going to
that
mention it.
way?
We are not going to mention it. The DBA will mention it. Normally that automation process nowadays, right? They will go to particular the front end tool. They will make them user ID and password. Then it will create the user ID for the database based on the roles. Then it will allocate automatically for that user what is the based on the roles. It will allocate the spool space, one particular
Oh,
user. That
oh,
spool space you have to use it. Okay, no other space you cannot use it. For example, you are running a complex query that is
mhm.
requiring more than the spool space, you cannot run that query.
Okay.
You will get another like spool space issue. No more spool space
Oh,
issue. Okay,
oh,
the spool
oh, oh.
space is nothing but unused permanent space which is used by the system. Okay, Teradata. So similar to a permanent space, spool space also you have to define a maximum amount when you are creating the user. Okay, and also the spool space is divided by the number of amp. So whenever you are creating the user, right, that time the spool space, the maximum limit will be assigned. So this is like something like a manual query, something like the DBA will use that. So create username. This is like data warehouse production admin. So admin user ID they
Okay.
are creating from data warehouse PRO. That is one of the, might be they are having some database as permanent space is this many bytes. Out of this, spool space is this many bytes. This something like 2 TB or 2 GB, 20 GB or something. This 20 GB can be divided into all the amp. If I have something like 10 amps in the database, then the spool space will be divided into 10 amps. Okay. So when will you get no more spool space? Whenever, for example, if one of the amp is getting skewed, okay, if you
Okay.
are not selecting proper index, right,
Then,
for the particular
uh,
table, if one amp will get skewed, right, it will get more values. So it
oh,
will have some space. That space also it lies. Then you will be getting no more spool space. So
oh,
we have some 4 amp system. If 200 GB is allocated for totally for the spool space, like 24 amp system, then each amp will get 8.3 GB spool space. All other amp is using within 8.3, but one amp is using 10 GB. Then you will be
oh,
getting spool space issue. No more spool space. Okay, got it. If any one of the amp is getting issue, then you'll be getting no more spool space issue. Okay, even
okay.
if the query is skewed, then definitely you will be having that spool space issue. So to avoid that spool space issue, what you need to do? First of all, you need to run that query. You go for the explain plan. So if you are running on query, right? For example, you are running select distinct of some ID, okay, product ID from the table. It has so many product ID. You are running some select distinct of row ID, something like you are making some inner query and then you are making some distinct value. Then it is taking a lot of issue and then it is showing like no more full space issue. It has been errored out. Then what you have to do, you have to go for explain plan for that query. Then it will show you where is the error. Okay, so you do collect stats. Okay, you do collect stats, check whether the table is a set table or multi-set table. You go for multi-set table. You are fetching on table, right? Selecting a table. That table you check it whether it is a set table or multi-set table. Even insert statement also you'll be getting some small space issue. It will take a lot of time to process it, insert it. So why? Because you are creating a set table. While inserting it, it will take a lot of time to insert. It will be checking the duplicate, right? Then it will be taking full space issue. That time you will create a multi-set table. Then it will easily it will load into the table.
You said like if you create a multi-set table, then this issue will be resolved. Na? That's what you told, right?
Yeah, yeah. Why? Because you are having set table. Set table will check each and every record. It will check the duplicate, right?
If we create the set table, then this skewness problem and all will be resolved, na? Then there will be no spool space error, no?
No. Set table, you are inserting the record into the set table. Something you are selecting in different table. You are doing some insert into select operation you are making. So it will be selecting some queries and then you are loading into a set table. This time the set table will check each and every time. It will check duplicate. Okay, duplicate check, right? Whether it is a duplicate record or not, a full row duplicate it will check. So even though it will not insert duplicate record, okay, set table will not insert duplicate record. Okay, it will you are going for insert into some select star column, it will not insert duplicate record, but each and every time it will go and check whether it is a duplicate or not. So that is why it will take a lot of spool space. You will be getting an error out. That time instead of set table, you go for multi-set table. You load it and then if you have any duplicate, you can rectify it. And also you go for explain plan. That explain plan, you check the join indexes. Okay, how the join indexes is, whether it is going for one amp operation or two amp operations. Join index you check, and you check something like skewness also. Okay, so the explain plan I will tell you after some time. Okay, while checking the some query, I will do the some explain plan. That time you can get to know that. Check for proper index whether it has been indexed properly defined or not. Sometimes no index also it will be available. Something like no primary index table. So that time you will not have some spool spaces you will be getting. So that time you have to do it. Okay. This is what the spool space you will be getting another. These are like something like spool space. Definitely you will be getting this issue in real time. Okay. So that time you have to go for the explain plan and then you have to check whether the first thing is you can do collect stats on the column. Okay, collect stats on the column. You check multi-set table or set table. So then these two things you can do immediately. Okay, then you can check some index column, indexing, join indexing, how the indexing is, whether it is going for something like Cartesian product or not. If it is going for Cartesian product, definitely it will have lot of spool space. Okay, to avoid that you have to do some join columns very correctly. For that you can go for some join index you can create on top of the table. After this temporary table, we will go and see the join index. So join index you can create to reduce that kind of issues. Okay, and the skewness also it will be showing you whether you have the particular column is having more duplicate data, then you can avoid the data while bringing it itself. Okay, something like you can go for rank column, you can apply some dedupe logic. You can remove that duplicate on the particular column by using some rank function, the qualify. Then you can go for the temporary space. What is the temporary space? It is the amount of space. Okay, it is the amount of space used by the global temporary table. Okay, temporary space used by the global temporary table. Got it? What is global temporary table? I will tell you. Global temporary table, I will tell you. These are the three different spaces are available in Teradata. So for example, here, this database we are having, right? We are the admin for this database. In real time, you will not have access to this particular page. This tool you will not have access. So here, this is what my database. I'm going to create the database. I can create a database and I can create a user. If I want to create one database in the sense, you will have multiple database inside the Teradata, right? So I'm going to create one database. So database name it is asking, right? Asking who is the owner, and it's asking the permanent space, correct? Spool space and temporary. So this is what it will ask. So either it is a fallback. Fallback means even every space the database it will have one more memory. Before journal, after journal, even journal concept also it will take a lot of memory.
Then if we set all these options here, then all the tables, the database will be by default will set to these properties.
Yes, correct. The entire database itself it will be a fallback. Before journal, after journal. Journal is nothing but you are writing, inserting, updating record into the table, right? Like we are having some paper and then we are writing it. If something goes wrong in between, how the data will be stored, where up to where it will be stored. That is what the journal. I will tell you. So that is also same, right? How it is going to be. So it is like a journal. Okay. These things they will be giving us. This one we will not use, but in real time It will be automated process. Okay, they will not use like manually. They will have some tool. We have the temporary table. We have three different temporary table. One is like derived table, volatile table, or global temporary table. Okay, global
Okay.
temporary table, and the third table is we will call it as the volatile table, volatile temporary table. What is this? We will see one by one. So derived table, we don't have control. Okay, derived table we don't have control. The Teradata will take care of the derived table. So something like inline views in Oracle. Okay, inline views, you know, right? Whenever you are having some subqueries or joins or anything else, we are making alias name, the table alias, right? Or we are making some subqueries. For example, this is the query we are making. Okay, so one query we are making, some subqueries we are making. That queries we are having some inner query we are aliasing like A or B or something. We are making this query as A or B or something. So this is one query like T we are making. So what is this T? Whenever you are going to execute this query, that time it will execute this inner query. At this instance, it will execute this query. It will save this result into a table called T with the product ID and sales. A table will be created. It will be called as T. So from there, it will take the outer query. And once the query has been executed, this table will get vanished. This table will not be available. If you are going for select start from T, it will not be available. This is called derived table. Teradata, it is called derived table. Okay, derived table maintained by Teradata only. We are not able to create any table. So next one is like volatile temporary table. So what is that volatile temporary table? Normally, if you are doing some intermediate calculations, right? Intermediate table, you want to create storage of. You are having very big query. That query you are going to divide that query into multiple stages. Like you are storing one data into a table, resultant of this table you are storing into another table, then another table you are doing some transformation logic, another table, then final table you are loading. Instead of doing all the logic into a single table, single query, you have split
Like
that query into multiple temporary table.
like stage work and final tables or
No, that is
how?
different. That is different. That is physical table. This is not a
Oh,
physical table. So this is a physical table only, but it
okay.
will be created only that instance. Okay, once that session has been completed, that job has been completed, this table will get vanished. Automatically it will get dropped. This table will not be available. Okay, the space will not be used, the data will not be available, and the structure of the table also will be get vanished.
Okay.
Global temporary table also, it's a temporary table. Okay, so you can use it for some other purpose, but the DDL, okay, the structure you are creating something, create table, table name you are using, right? That
Yes.
structure will be maintained for other sessions also, for other users also.
Oh,
So if I am the user, I can use one table called GTT underscore one. That is one table. It has some columns. I'm using. So I have used the table for to store some data, and then I have come out of the session.
okay.
If you are another user, you are entering into the database, and then you want to use the table, you can use it. Once you come back, your session data will get vanished, but the structure will be maintained. The structure will be maintained in the global dictionary. Got it? So I'm going to
Okay.
create one volatile table now. Okay, I'm going to create one volatile table, then I'll show you. I'm going to create one volatile table. For example, the retail database I will create. Okay, so in there you can mention create table name and the retail dot something, or so I'm going to execute the syntax called database retail. I'm going to execute the syntax called database retail.
Wait.
That means no need to mention the database name every time. Okay, one time I have mentioned here, then all the times it will be retail table only, retail database only. So I'm going to create a volatile table now. So create volatile table, table name, something like log it will take, it will be maintained for log, department number, average salary, maximum salary, something I'm creating. On commit preserve rows, it will preserve the data. If you don't use it, then it will not save the data. If you don't use this on commit preserve rows, it will not store the data in the table. So here I'm going to create a volatile table. Table has been created, right? In this instance, it has been available. So I'm going to insert some record into the table.
Generally, in which cases in real time we will use these type of tables?
Yeah, that is what. So you that I told, right. So if you are having very big query or very complex logic, you are going to use it. You can split up that complex select query into some small select query. You can store it into multiple volatile table. After that, you can combine it and then you can have it in the single table. Okay. Then after combining it, no need to have no need to keep this table, right? What is the use of this table? It will occupy space if you keep it. Every time if you are creating a table, temporary table, it will occupy the space, right? So instead of that, we are banishing the table. For that purpose, we will go for volatile table.
Yeah.
So now I'm going to insert a record into the table, volatile table. I'm going to insert it. So one row has been inserted. So if I go and check now, select star from the table name, it will be available. The data will be available. The table data is available, right? So simply you have to mention create volatile table. That's all. If you go and check now, so select star from the table. If you check the definition, it will be a create set volatile table. It will automatically create set table only. If you want to create multi-set table, you have to create multi-set table here. Create multi-set volatile table on the table. Fallback has been enabled for this. This is a volatile table. Clear?
Okay.
Set table, multi-set table, you can create it. So now what I'm going to do, this is, I told, right, only that instance only it will be available, right?
Okay. Yes.
Instance only it will be available. I'm just a log out. I'm doing some log out. If you have created any table, if you log out and log in also it will be available, right?
Yes.
But
here
volatile table will not be available. See now,
will-
volatile table will not be available. So it's showing like, so I will execute database also. Okay. I will execute select star from the table name. The table showing like does not exist. Why? Because everything will get vanished. If you don't use on commit preserve rows, if you don't use, for example, if you don't use on commit preserve rows, what will happen? It will not store the data. Okay, I'm going to create a volatile table. The table has been created. After that, I'm going to insert some record. So one row processed, but if you go and check now, data will not be available. See now. If you use on commit preserve rows, then only the data will be preserved. Same instance also, it will not be available. Okay, this is called volatile table. Are you clear? Volatile table. It will not have that structure as well as data will be get vanished.
Not even structure also.
So whenever you want to have a table, it should not be maintained after the session. After the job completes, then you can go for the volatile table.
Okay.
Global temporary table is only difference is the structure will be maintained for all the session. The data will not be maintained. Data will get vanished, but the structure will be maintained after the session also in the global temporary table. Why? Because it's a global. Anywhere, anybody can use that. Create set global temporary table. So retail.gtt, this one I'm creating it. Okay, on commit reserve rows. Just it's a global temporary table. Right, it has been created, right? So after that, if you want to load some data, the GTT, just I'm loading the data. If you go and check, this data will be available now. Select start from the table name to be available. Okay,
Yes.
be available. So you are, after that you are logging off your instance. You are logging off your instance. Again you are logging in. That means your job has been completed. Assume that it will log out, right? Once job completed, it will log out.
Yeah.
Again you have logged in.
Only structure will be maintained.
Yeah, only structure will be maintained. Okay, so retail I need to make it. So table is available, but 0 rows returned. This is called global temporary table. So structure will be maintained. Okay, but no data will be maintained. So others, if you want to use the same structure, they can use it. No need to create and every time. So other users, and also that instance only it will be available. The other instance, the data will be different data also you can use it. For example, if I'm the user, I'm using this instance, some other data. The same time you are using the same global temporary table in your user ID, it will be different purpose you can use it. Okay, so that is called global temporary table. So this is the three different tables which we are available. Derived table we don't have control. The Teradata will take care the control of derived table. So we have DBC, right? DBC or database computer. We have different tables are there in the DBC. Different tables are there in the DBC. So dbc.tables, it will give you the all the tables information. dbc.tables, even tables V is the view on top of table. They would have created one view name. So if you check this, so they have created one replace view name as select dbase dot database name everything. Okay, table they have done with left outer join. They have created on view. Okay, so this is the view we do have. On the dbc dot tables v we can select it. If you are selecting it, you can check all the tables. So the database name, table name, so how many times the table has been created or altered. So alter or replace the version. Table kind is the either it's a table or view or indexes. So you can see the different table kind. Okay, and then so table kind I will tell you. So this is the abbreviation for all the table kind. Okay, so no PA table, it will be your table kind O. Okay, T means the table, V means the view, H means it is a instance or constructor method, and M and F. F is nothing but scalar UDF, M is nothing but macros, J is nothing but journal, the indexing, join index, I is nothing but join index, G is nothing but trigger. So we have something different table kind we have. So it's a fallback or no fallback. So that is the protection type. Journal. So whether we have journal or not. Who has created this table? Okay, what is the syntax of the table? So when it has been created, who has created? Okay, last altered by, everything will be maintained here. Whatever the SQL we have executed, right, it will be available on the history. View history, show history here. So whatever the SQL we have executed so far, right, whatever we have executed will be available here. From the beginning, whatever we have executed, it will be available here. So all the SQLs will be available here. pc.users, it will give you all the users. How many users are there? It will give you the users list. So different users. How many users we have? dbc dots all space. You have all the space. What is the bproc number? So database name you can go for retail. Okay, account name, table name, how many space, permanent space, school space it has been taken. It will show you where you can mention like name equal to, and the table name we have created one table, right? Morning we have created some table like retail, the country table we have. So current permanent space, this is the space it has been. School space it doesn't. So whenever we are running any query only, it will take school space. So permanent, it doesn't take any much space here. So while running the query, it will take the spool space. Then dbc.index, it will give you all the index informations. You can run Teradata in two different mode. One is Teradata mode, the ANSI mode. So whatever we are running it, right, it's a Teradata mode. So you can check all whenever you are running Teradata. It's by default it will create a set table. It is not a case sensitive. So whenever you are running any query, it will be automatically commit. Implicitly it will commit. Supports all Teradata commands. It follows bteq, begin and end transaction mode. So ANSI mode is different. So ANSI mode by default will create multi-set table and case sensitive also, the query. Even you can check that which mode is running. Help session, right? Teradata mode. Okay. I told, right? Our database is running a Teradata mode. In your database, if you want to check, you can go and check real time which mode is running. So by default, it will be Teradata mode only. So index, you know what is that indexing? Now those primary index, secondary index, partition primary index, and no primary index, right? This join index something different. This join index, whenever you are creating a base table, you will have the indexing. But you are querying the table based on some other column. Okay, some other column. So that time, the performance wise, it is not that much improved. Why? Because you have created index on one column, but you are querying some different column. That time you will not have that much amount of performance. This join index, you are telling Teradata to create. Okay, you are creating a join index. After that, the Teradata will take care. We are not going to see that join index. We are not able to see that join index. Okay, so if you are going for index creation, the Teradata will take care. Join index, something like views, how we are creating the views in Oracle, right? On top of a table, we are creating the virtual table to access it multiple tables. You know, right? Views, what is views in Oracle? It's a virtual table. So like you have multiple tables are there. So always you have to fetch the data from multiple tables every day. So every day, instead of writing a query to join all those and then create, take the record, you'll write one time as the view, you save it in the database. Then if you are making select star from view, then it will pick the data. We are not going to run any query. The Oracle will run it. The same way, the join index we can create, okay, created by user, but maintained by the Teradata. It is an optional index which may be created by user. It will be for additional efficiency. It will eliminate the base table access. The main thing is it will eliminate the base table access. Whenever you are going for something like select star from the table name, you are not accessing the primary index column, which we have already created. You are not having that column. So you are using some other column. Then Teradata will check that whether we have created join index for that column or not. If you have created, it will run that join index and then it will pick the data. It will eliminate the aggregate processing, reduce the joins, and reduces the distributions, redistributions. So how it will reduce the redistribution, I will show you. So this is what. So you have 7 different types of join indexes. 7 different types of join indexes. One is single table join index, multi-table join index, multi-table compressed join index, aggregate join index, sparse join index, global join index, hash join index. These are like the 7 different join index are there in Teradata. So the first one we are going to see like single table join index. You assume that you have table called employee underscore table. You have the table called employee underscore table. So this table, this employee underscore table is having primary index of some other column. Primary index of some other column, but we are not going to access that particular column as primary index. So for that we are going to create one join index on top of the table. On top of this employee table, we are creating one more indexing. Create join index, index name employee underscore index as select star from the table name, primary index of department number. In the base table, employee number may be the primary index, but in this index table we have created department number is the indexing. Single table join index duplicates a single table. It will duplicate the single table but changes the primary index. User will only query the base table. Okay, only query the base table, but parsing engine, right? The Teradata will access this join index. Will access this join index to fetch the data based on department number. This is called single table join index. You are having one table called employee table. Okay, employee underscore table.
Okay.
It has something like a column called employee number, department number, first name, last name, all those. Okay.
Okay.
Check. So this table has employee number, department number, first name, last name, salary, all the column. In that table, we have created employee number as the primary index. If you are making show select star from the employee table, it will show you this table structure only. But on top of this table, we are creating one indexing, single table join indexing. Okay, if you want, I will create and then show you. You are creating this table, the retail employee table you have created. Okay, if you are making like show table name, it will be available. On top of this table, we are creating a join index. Create, okay, single table join index, right? Join index of on this table only. Okay, create join from this table. Okay, so we have to mention that the primary index of which column we are going to make, and also join index where we are creating it. So this time it has been created. Okay, but This time, if you are going for something like, so select start from this table, show table, table name, it will show you that employee number as the primary index. Employee number is the primary index. But whenever you are running query based on department number, the parsing engine will take this query. This index it will take. It will be faster. Okay, this is called single table join index. This index we cannot able to see that. Our Teradata will take care. But this table we are creating a single table, right? So multi-table means instead of single table, we are going to use multiple table. The joins we will use. Okay, it's a join index that involves two or more tables. So join operations to eliminate the data redistributions. So I will show you what is that. So here we are having the employee table, right? Employee table as E, inner join department table as D. We are making something column, right? This one, and we are making a primary index on employee number this time. So whenever you are going for something like joins on these two table, this join index will be invoked automatically. This join index will be invoked. Clear? This is called multi-table join index. Multi-table join index. Compressed join index is nothing but, so instead of the compressed join index is nothing but repeating the, is designed to save the space, not repeating the repeating values. Same column names we are not selecting it. Just simply we are making like select c dot customer number, customer name, order number, order date, order total. So this is like C, this is dot order from customer table as C, inner join order table as O, and the same thing we are make it like. Okay, so if you are making first bracket, it will assume that the first table, second bracket it will take it like a second table. It will be very easy to understand by the Teradata. So this type we will maintain in the compressed join index. So this one just we will create it whenever you are going for the something like explain plan. I told, right? Explain plan. That explain plan, it will show you like create join index, something it will tell you. That time you we can create it join index. That time you should know what is join index, either single table join index, multi-table join index, aggregate join index, something, but you will use some group by columns. So if you are using some count and group by, that select statement you can use it like aggregate join index. Sparse join index, something like where class. So you are using some where class, right? Something like where class we if you use that where class. So join index that doesn't use every row because it has a where class. Why? Because you are restricting the data. It will not use that all the rows. Anyhow, you have restricted the data from this year alone, 1999 alone. So this is called the sparse index. Okay, so whenever you are restricting the data, it will go directly to this view and then it will show you. This is like a sparse. And hash index, so something like hash value will be created. We are not going to handle it. The Teradata will handle it. Okay, create hash index, index name, department number, first name, last name, and table name. Okay, one hash value will be created in the amp level, it will be created, it will be maintained. We are not going to create it. So these are like different types of join index which we are using it in the Teradata. Join index is something like views we are creating. We are telling Teradata instead of using this indexing column, you use another indexing column. That's all. We will see the Teradata join strategies. So Teradata join is different and join strategy is different. Join strategy is nothing but Teradata optimizer internally will do this type of join strategy and they will make the joins. Okay, normally we are going for different table joins, right? So how it will take the joins? So we will see now. Whenever we are doing the joining, right? So on the columns, Teradata will look for the join strategies. So based on which is the least cost plan, it will execute and then it will do the joins based on that. Okay, so it will consider three main parameters. One is like a table size. So how much is the table we are going for, like either left table, right table. Which table is bigger size or lesser size? It will go for table size, and then the primary index information, and then stats information. Like we have four types of join. One is merge join strategies, nested join strategy, and row hash, and product. Okay. So first of all, merge join, it will have four different type of strategy it will follow. So Teradata will take care. We are not going to handle it. Okay. So Teradata based on the join column, it will take care. Okay. We are not going to see this. Okay. We are making the join the column name. Okay. Whatever the join condition we are making, based on the join condition, it will go for the join strategy. The first strategy will be merge join strategy one. Okay, so it will have one UPI column. So both are like UPI. So as we have seen in the morning, so if both are in UPI, it will be on the same AMP. The data will be on the same AMP. Row distribution or data distribution will not happen for this scenario, and the data will not be moved to spool space also, and it will take in a very faster way. Okay, right? Since the data are in the same local AMP, it will make the joins and it will create the results. Okay, and no data has to be moved into spool space or into the others. No distribution will happen, and join can perform in within the local AMP itself. So that is why it is performed very well. Okay, next join strategy is, one is UPI column, the join, whatever the join condition we are making, one is UPI, the other one is no PI. Okay, so it's not a PI column, right? So here consider two tables like AMP1 and AMP2, and two tables are department table and employee table. If you consider this table, if you look at this table, so here you have the UPI column. In departments table, department ID is the UPI column. Okay, so unique primary index. In employee table, employee number is the UPI column, unique primary index. Okay, but in employee table, the department number is no PI column. Okay, so we are going to join based on the department ID. So you this department ID with this department ID. So one UPI, one no primary index. Okay. So if you are going to join this, how it will be? Like you have the data like this, right? So you have the 10 and 20 here, 10 and 20 here. Okay. So here I have 30 and 40. Here I am 30 and 40. So 30 is available here, right? Department ID 30 is available here. So this employee table will make either it can handle two way. One is it can move the small table into the spool space and you can do the joins. Okay, otherwise it can handle whatever the data is for joining. This 10 is needed, right? So for example, here 10 is available, 10 is available. So it will make department name is sales, correct? For this one. And 20 is available, 20 is available, it will make market. But here, if you look at 10 is not available here. Okay. So what Teradata will do, whatever it is not available, it will move this data to spool space, this space. So here it will make this record, okay, 10 and 20 to spool space, and also this record, right, 10. So 10 from here. So 2 and 10, it will be moved to the spool space. Okay. So then it will make 10 and 10 here, then 20 and 20 here, and 10, this 10 is available on the local app. It will do the join. Okay. So this is what it will make the join conditions. This is like a second join strategy. Okay, one table will be moved to spool space. The third join strategy is, so here we are going to see this department table and manager table. So both are like no PI column. Okay, so here I have in manager table, in department table I have manager ID, something manager employee ID, and manager table I do have like manager number. Okay, if you look at here I have 1 and 4, here I have 3 and 4. Okay, so 4 will get managed, right? 4 will get joined, but 3 it is not available. So here 3 is available here. Okay, so here 1 is available here, so 5 is not available. 5 is available here, but 1 is not available. 1 is available here. So what it will do in this case, Teradata redistribute both the tables. Okay, it will make, it will swap it into the spool space, redistribute. So whatever the date needs, it will redistribute.
Okay.
Based on
It
that, it
will
will
collect yeah, all those
on the
data into the spool space,
spool
and then
space,
it
and
will
then it will
join.
make the joints. Okay.
Okay.
So
Okay.
based on that, it will make the joints. So it will bring, for example, this is the first table, this is the second table. It will make 3 and 5 here, 3 and 5 here. So the same way, 1 and 4 here, 1 and 4 here. Then it will make the joints. So this is what it will do on the third strategy. The fourth strategy
Okay.
is small table and big table. Okay. So if I have 1 million record in a table and some 10 records in another table, so it's very comparatively very less. Okay, 10 means or 100 means it's very 1 million, and compared to 100 is very less. So what it will do,
Yes.
whichever is having like very less table, right? It will make the less table into all the AMP. It will redistribute. The Teradata will duplicate the smaller table across all the AMP. Then it will, all the data will be on the same local AMP, right? Then it will make the joints. Okay.
Joints.
So
Okay.
whatever the, for example, 20 and 10 and 20, 10 and 20, in all the AMP, it will make the spool space. It will bring the data into a spool space, and it will do the joins. Okay. So this is what fourth join strategy. Next join strategy is nested join. This is what we will use in real time. Okay. Nested joins, like
Okay, in like in real time, how we should take care of
no,
these
no, no. This is what
join
we are going to take
strategies?
care.
We are
Like
not responsible, right?
we are
Yeah.
using the primary index, right? Indexing column.
Yes.
So based on that, it will take.
Okay.
So normally, if you are joining based on the UPI
Okay. Like
and
internally, what happening
internally, it will happen.
procedure, right? That's it.
Yeah, internally
Yes.
it will happen.
Okay.
So sometimes how the Teradata. So you are getting spool space issue, right? So
Yes. Yes.
if you are
So.
not joining properly, then you may get spool space issue. It will bring all the data into a spool space. Redistribute will not happen. So you are getting some. So this is also bringing the data into spool space,
Spool
and you
space.
are doing some calculations, arithmetic calculations. You are doing some sorting or
Okay.
distinct something. Then spool space will become,
Uh,
it will occupy completely. Then it will get failure. So next one we are going to join. So for example, this is employee table. This is department table. This is nested join. Okay. So here in employee table, employee ID will be UPI column. Okay. UPI column. Here in employee table, department ID is non-unique secondary index. We are creating this also index column. This is indexed column. So since these are indexed in column, right? So we are going to join with one more table called departments table. This is also department table. So we are going to join with inner join, right? Inner join department table, department ID. And also we are going to use some filter conditions. Okay. So apart from the join condition, we are using some filter conditions.
filter.
So here we are using filter condition is department ID equal to 10.
Okay.
Okay. What it will do, Teradata. So only 10 is needed, right? So it will redistribute from this 10 to this AMP also. Okay. So why? Because it is going, anyhow, it is going to limit only for 10 only. So other record it no need to have, right? So it will bring the 10 into spool space and it will make the join. So that is why if you are if you want to restrict more data for the joins, restrict it. So the spool space will get, it will not get more space. Okay, and also in this case, the department ID is again indexing column only, non-unique secondary index. So indexing column with indexing column, it will make easily the joins. Okay, so that is the very precious method which is available in Teradata. This is called nested join. So if you are making any where class apart from join condition, it will go for nested join. Then we have product, okay, product join. So Cartesian product. If you don't use that condition, right? Join condition. We are using join table, okay. So A table, comma B table, inner join B table. But you are not using join condition. You are using some other condition. Here you are using select E dot, so E dot emp D dot department from employee table, comma department table, but we haven't give employee dot department ID, something like we need to give, right? We haven't give, some other var class we have given. So what it will do, if you don't use condition, right, join condition, it will go for Cartesian product. So it will take every record in the first table, it will join with one
All
record
the
in the
records in the
next
okay.
record. Then again second record, it will go for all the record. Third record will
All
go for.
records.
If you have 10 record here, 10 record there, then it will make 10 into 10, 100 record it will create. So this is what it will make the product join, Cartesian product. So this is what Cartesian product. Even here we are not going for something like var class also we are not going. So var class also missing. So that is why it will go for some Cartesian product. Okay. And we have
What is
exclusion
that
join.
where date like something?
Yeah, something.
Where EMP like.
Yeah, something we are giving, right, some var class, but here we haven't give join condition. Join condition also we haven't give, right? But simply we have given one more var class. It will go for Cartesian product and then it will go for some var class. After the result, it will go for var class. But below, even we haven't give the var class. Simply we have given A table, comma B table. That's all. We give some var class also, it will restrict some data. But if you don't give var class,
then it will cost more spool.
Yeah, that is what Cartesian product. Okay. It will cost lot of spool space. It should not happen. Should not happen. Okay. So to avoid that Cartesian product always. Normally you have to check whether it is going for product join. Okay. And one more join type is exclusion join. Okay. Exclusion join. Exclusion join is nothing but not in condition you will make. Whenever you are going for not in condition, first it will execute this one, whatever the data, it will avoid that particular record, and also we are using that var class also. So this is called exclusion join. Something like it will not go for the not in condition. So this is like exclusion. Okay. Then hash join. Hash join is nothing but by default Teradata itself it will take care about the hash join. Okay, we are not going to do it. Okay. So some hash algorithm it will create. For example, if you consider these two tables, employee table and we have the department table. In employee table, employee ID will be a UPI. In departments table, department ID will be a UPI. Okay, here I have 10, here I have 20. You are going for employee table, inner join department table. You are making on EMP equal to manager employee. So you are not going to join with this column, UPI column to UPI column. You are going for department, this one. Okay, so EMP with UPI with some non-UPI column. Okay, this one. Okay, so one you have, but you do not have 99, 88 something, right?
Yes.
So it doesn't have. So if you are going for inner join, so what it will do, the hash join process is where the smaller table is sorted by the row hash and duplicated on the every AMP table. So whatever the table is small table, the Teradata will make this sorting algorithm, and I need only for inner join, right? Inner join only 10 is there. Sorry, manager EMP 1 is there. Other manager EMP is not there. So here manager EMP 70 is there. Only 70 and 70 it will make the join. Okay. Other record will get filtered out, right? Inner join. So it will make the algorithm like sorting algorithm, but it will make the joins. So these are all the join strategies we have in Teradata. Okay. So normally it will go for merge join and nested join only. So, but anyhow, we are not going to do anything on the join strategy. Okay, so Teradata will take care. So we will see some SQL queries like in a faster way, like something they're not going to execute one by one. We will see something like what are the queries we have. Tables, where table name, like okay, I'm going for some, whether I'm going to check whether I have the customer table, the database. Okay, I'm checking abc.tables where table name. Even I can restrict the database name equal to something. So you have the table name called customer, right, in retail. So select star from retail dot customer. So you have two records. So I have something like a customer table. It has country ID. Okay, it has country ID, and I have table called country underscore join. I think so. So country table. Okay. Here I have the country ID 200. Okay. Here. So in customer table, I have like something like 200 only. Okay. So I'm going to join this table. So you have one more table, city table. So from city, you are going to join with other table. So you have customer join. First table is customer join. So I'll be taking this table, this table. We will see now joins. Okay. So how to make the joins. So here it might be the customer ID will be a primary indexed column. And in this table, country ID will be the primary index column. Okay. Primary index column. So if I want to join these two tables, so common column is country ID, right? So if I want to do the inner join, how will you do the inner join? It's very simple. So I'm going to do inner join. So I will check what are the columns are there in the table, right? First of all, how will you do the inner join? Inner join is nothing but common record between both the tables, correct?
Yes.
So here I will go for select column names from first table. So first table is customer underscore join, correct? Customer underscore join. So I will make the database name. Okay. So inner join. Second table is retail.country, retail.country. This table I will make it like A. This table I will make it like B. Okay. So then on condition on A dot country ID. Okay. So the common column is A dot country ID equal to B dot country ID. So this is what you have to make. Then you have to go for A dot customer ID. Customer ID. So A dot customer name. So whatever the column you have to select it. A dot mobile number, MOB underscore number. A dot email, comma. A dot country ID, right? Country underscore ID, comma. So another table is B. B dot country name. Okay. So country name. So you have to select it in this way. This is called inner join. So you have 6 record here. So you are getting 5 record only. So one record is getting filtered out. So what type of join it will make? What type of join strategy it will make? If you see here, so which is the do we have UPI column? Yes, you have the customer ID is the UPI column. Okay, but here we are making country ID. This no UPI, correct? So in this table we are making this will be a country ID is the primary index. Okay, country ID is the primary index, not UPI column. So you are joining PI column with no PI column. Okay, that is what it will make the join. So it will make the redistribution, the spool space. Okay, so how it will be bringing the data. So based on that, it will do the redistribution. But since we have very less value of data, so it will bring that easily. This is what will happen. This is like inner join. If you are bringing, so inner join, you know, right? So common record both the tables. If it is not matching, it will not fetch. So that is what the inner join will happen. These are all the tables. Okay, what we have the database, we have the same record. So here I have record here. So if 200 is 200 matching, you will get record as India. 204 is matching, you will get UK. 202 is like USA. 203 Singapore.
Only matching records.
Yeah, 205 it will not come in the inner join. It will get filtered out. Why? Because 205 is not available here. If you are doing left outer join, so left outer join, all the record from the left table, right?
Left table.
Matching record from the right table. If it is not matching, you will get null value on the right hand side. And also right outer join, all the record from the right table.
From the right table. Yes.
And then matching record from the left table. If it is not matching, you will get. Okay. So in this scenario, so for example, I want to find out in which country I do not have my customer, and I can go for right outer join, and one more condition, customer ID is null, then you'll be getting this record alone. This way you can find that so the country where no employees are working. Same way here also I can go for some var class here, where so b dot country name. Okay, b dot country name equal to India I'm making. Okay, India. So this is like nested join, right? So only India. So how many of them are India? It will bring the data. So this is what two members are from India. So it will go for nested join condition now. Instead of inner join, if you want to use left outer join, you can use left outer join. Left join. I'm removing this var class. Okay, var class. Just you are selecting it. It will give you that. Okay, 205 is null on the right hand side, right? So if you are making like right outer join, right join or right outer join, so this is what it will make. So you will get a null value on the left hand side. China, I do not have any customers. So why you are getting null value here? If I want to get the customer ID, then I have to go for b dot country ID. From the b table I can get the country ID. Okay, then which country it's from. If you want to get only this country, then I have to go for, okay, in which country I do not have employee, then I can go for where a dot customer ID is null. Okay, you will get only that record. So you will not select these columns. You will not select these columns, only these columns you will select. So you will find that, okay, in this country only I do not have any customer, right? So this is what you can go for right outer join or left outer join or full outer join. Any join you can go, and then you can bring the data. If you have like 3 tables or 4 tables, how will you make the joins? For example, you have one table called customer join underscore 3, right? Customer underscore join 3, customer underscore join 3. You have one table called here. It has city ID, not country ID.
Mhm.
Then you have, I think you have a city table. Select star from retail dot city. It has some city ID, right? City ID, and you have the country ID. These 3 table you have to join it. These 3 table you have to join. So here city ID, city name, country ID, right? So in this table you have country table. You have to find out how many of them are from India. How will you make from this table? So first of all, 3 table join, right? So the same way you have to write. Select column name from first table. First table is this one, right? Table. Inner join. Whatever the join you want to have, you can use a join type. Inner join. Second table. City is the second table, right? This table and this table, we have the common column called city ID. They are making this as a A. This will be B. So on. First you have to join with 2 tables. On A dot city underscore ID equal to B dot city underscore ID.
City ID.
Okay, again you have to do inner join. Inner join.
Mhm.
Okay, inner join, third table. Third table is, this is the third table, right?
Fine.
Table, and again on condition. B dot country equal to C dot country.
Retail city C bit.
Okay, C dot country. So you have
Retail
to
city C.
city,
Yeah.
you have to put here whatever the column you want to have, you can select it. Whatever the column you want to have, you can select it. So A dot customer ID, email, A dot city ID, right? ID, comma, B dot city name.
What are the columns are there in the join 3?
City name, right?
A, right?
So name, city name is there in B table, comma, B dot country ID, B dot country ID, C dot country name. This one will be country, not city. City we have already joined, right? This will be city. Okay, this is what join. If you want to make only for India, then after this you have to go for var class. Var C dot country name equal to, so you can say like these many country customers are from India, you know. So okay, so you have 5 customers are from India. So this is what you can say. For example, you are having one more. How many customers are from Chennai? Okay, and the condition and the city name, right? City name is there in B table.
City name equal
B dot city name equal to Chennai.
Chennai.
So you will make this way, right? Okay. something you are making, you are getting some, this is a joint condition, you are getting some value, but sometimes you are not getting value. For example, here you made it like USA. Anyhow, it will not come. Why? Because
Yeah.
USA there is no city called Chennai, right? Zero
Yes.
record. If you are running join query, if you are not getting any record or you are not getting corresponding value, how to backtrack it? So first of all, you have to run like this. You remove one condition, you run it,
Okay.
you check whether the data is coming or not. Yes, it's coming. Then you can identify, okay, so in USA, I have only city name called New York. That is why I'm not getting that for Chennai. Or you can check whether I have Chennai in the, whether I have Chennai in the city. So I can run it. Yes, I have the data for Chennai, but it is there in country in India. You are making country name equal to USA. That is why you are not getting record. So you have to backtrack in this way only. If you are running any join query, complex join query, if you are not getting any value, you have to run it this way and I have to find out. So I have table called employee. Okay, I have table called employee. If I want to find out what is the maximum salary for the employee, then I have to run it in this way, right? Maximum salary I'm running.
Yes.
Okay,
Yeah.
50,000 is the maximum salary. I want to find out who is getting this maximum salary. So can I run this way?
Yes, we can select name.
This will not run.
No need.
I want to find out who is getting this maximum salary. From running this, it will not execute. Why? Because this is aggregate function.
Select name from.
So I want to find out who is getting maximum salary, right? So I cannot go directly in this way. Name comma max of salary I cannot go. Why? Because remember this, if you are selecting a non-aggregate column with aggregate column, you'll get error. So for this, you have to go for the subqueries. Subquery is nothing but we have three different subquery. One is like single row, multi-column. Okay. This one will be inner query. This will be outer query. This select will be inner query. So for example, you are going for select. Okay. Inside one more select you are writing. So this will be inner query. This will be outer query. So inner query will be executed first. The resultant of inner query will be supplied to the outer query.
Outer query.
Okay. So normally we will run like single row subquery. What is that single row subquery? The inner query, right, should always return only one row. That is called single row subquery. For example, if I am running this query, what is the max of salary? I am getting this value, 50,000, right? 50,000 I am making here. Select star from employee where salary equal to 50,000. Then I will be getting who is getting that 50,000, right? Okay,
Yes.
this person only is getting maximum salary.
But we don't know, no? That is.
But 50,000 you cannot make it like hard coded value, right? Instead of
Yes.
this, you are going for subquery here. So if you are using this entire query here, then it will be a single row subquery. Single row subquery means this inner query should always return only one row.
Only one record. Okay.
Only one row. Okay. Then it will give you like the same result. Whenever that data is getting changed also, tomorrow 51,000 is the highest salary means that person will bring up. Okay. Multi-row subquery means the inner query is returning more than one row. Here, for example, the year wise I want to fetch maximum salary. So let's start from the employee. We have some data now. Okay. Whatever the data we have, it is available. So now I'm going to check what is the maximum salary for the table, right? Who is getting maximum salary? Okay, so 85,000. This person is getting maximum salary. Rekha is getting maximum salary. Then select max of salary, group by department ID I'm making. Okay, DEPT underscore ID. Each department I'm selecting maximum salary, right? What is the column? Department number. Department number. I'm selecting this particular query. I'm executing this query. So for department I have one record is coming, right? I'm using this one and I'm using each and my aim is to fetch every department who is getting highest salary. That is what I want to have it. So if I'm executing this query will not work. Why? Because if you are using equal here, okay, So equal or not equal, less than, greater than. Okay. Any operator here in the subquery, Teradata or any database will assume that this inner query is single row subquery. If you are using any of the relational operator, Teradata will assume that this is single row. But how many rows it is giving? Multi-row, right? This inner query is returning multi-row. So that is why it will not
So
execute.
in.
So you have to put
In.
in. So you will be getting salary in. Okay. You are getting salary. So you need to get 4 record only, right? 4 department you have, 4 record only you have to get, correct? So you are getting 10th department, okay, 65,000 is the highest. 20th department, 85 also is coming and 70 is also coming. Why? It should come only 85,000, right? Same department. So my aim is to fetch each and every department.
Only 85,000 should come.
Come, okay. So here I'm using select max of salary, right? From employee group by department number. So each and every group will be getting this particular record, right? This
Yes.
particular salary. So what is outer query? Select star from employee where salary in. So whoever is getting the salary, it will be coming. So that is why 20th department, 2 of them is getting the 85 also getting and 70,000 also getting. That is why 85 is the maximum salary for 20th department. 70,000 is maximum salary for 40th department. That is why inner query is returning.
In the same department, 2 employees are getting.
So why? Because this salary someone is getting in another department. Since you are using in class, it is fetching that. Okay. To avoid this kind of scenario, you have to go for multiple column. Got it?
Yeah, some other name or what?
So this one, instead of no, not other name. Instead of fetching the maximum salary alone in the inner query, you are selecting only max of salary alone, right? Instead of fetching maximum salary alone, you get along with the department. So get department also. Department,
Then,
select star from employee where department number, comma salary in, select department number, comma max of salary. So this is why we'll be fetching. Only one record is coming now. This is why multi-column subquery. So multi-column subquery also very important. So you know how to find a duplicate record in a table? You know, right?
distinct is.
No. Distinct will not give a duplicate record. This employee number you have to do group by. Okay. You take employee number as group by. You make the count. You make the count. Employee number, comma count. So I said right. So non-aggregate column you should not select from count. But if you are using this column in group by, you can select it. If you are selecting it, so if it has any duplicate, okay, 101 2 times is there, then you will getting some 2 or 3 something, right? If you want to filter out a record from a group by, then you have to go for having class. That aggregate function is nothing but, for example, select max of salary from employee. It will give you what is the maximum salary, minimum salary, sum of salary, everything will give you, right?
Yes.
Okay, but I want to get it who is getting this maximum salary. Then I cannot go for select first name comma max of salary. I cannot go. I cannot go for this way. First name comma max of salary. I cannot go. Why? Because this is non-aggregate. This is aggregate column. You cannot select it. So non-aggregate column you cannot select it. That is why it's telling the error. Okay. So I want to get it. Then only we are going for. I want to find out how many employees are there in each department. How many employees are there in each department? Select count of star, right? Count of star from employee. So if you are making count of star employee, it will give you total number. 6 employees are there totally. Out of which each and every department, how many employees are there? Then group by department number. It will give you. But I may not know. I may not know what is this department. What is this department, right? So for that I can select here department number. So this is non-aggregate column. This is aggregate column. You may ask question, how will you select non-aggregate column with the aggregate column? It should be in group by.
If it is there in group by, then we can go for.
Yeah, then we can go for. Okay, it is giving, right? it is giving the value. So department ID comma. Okay. So in which department we are having more than more than one employee?
Where count star is greater than
I will use where class, right? Where count of star greater than 1. Am I correct? It will not work out. Why? Because this is group by resultant, correct? If you want to filter out group by resultant, then you have to go for having class instead of where. Where means a physical column should be there. The count is derived column. So you have to go for having. Having is nothing but whenever you are
the
having
result of the
group by. Resultant of the group by. If you want to
group
filter
by.
out, if you want to
Then
filter
we should
out
go for having.
having class, okay, clear?
Yes.
So that is why we are making here, okay. So here making, right? So where is it? Yes. Here we are finding employee number, department wise count. We are finding something like employee number. So I want to find out whether we do have duplicate on the employee number. How will you find? I want to find out whether duplicate is there in the employee number. So you assume that you have 1 million record. 1 million record is there here. Okay, 1 million, 10 lakhs record is there. Okay. If you are making distinct of employee number, if all the employee number is distinct, you will get all the number, right? But I want to find out whether we have duplicate in the employee number or not. Can you make employee number group by? Select count of
Having
star
employee number greater than 2.
greater than 1. Okay, count of star from employee group by
Employee number having
group by.
employee number count.
So this is what you have to make. Then employee number, if you are using group by, you can select it
Employee
here.
number that there are.
If you are not getting any value, that means no duplicate. Okay, if you are not getting any value, you are not having any duplicate. Okay, so that is why you are having it. This one coalesce function normally we will use to handle null value. You can use it coalesce of any number of argument. Okay, argument 1 comma argument 2 comma argument 3 comma any number of argument you can use it. Okay, argument 2 3 like this you can use it. So what it coalesce function will do, it will return first not null value. It will return first not null value. For example, if the argument 1 itself not null value, it will return that value. So select coalesce of 5 comma 6 comma 8. I'm executing, I want to execute this statement. It will give you 5. Why? Because 5 itself not null value. If it is null, if it is null value is coming, then it will give you 6. 6 also null, then it will give you 8. So everything is null, then it will give you null only. So coalesce function, it will return first not null value. Got it?
Okay. In real time, in real time, when we'll go for this coalesce function for to retrieve what?
So for example, I have something like I'm collecting, okay, home phone number from you. I want to collect either home phone number or office phone. Some form I'm asking phone number. Enter your home phone number, office phone number, cell number. I'm asking these three. Someone will write home phone number. Someone will write office phone number. Someone will write cell phone number. Someone will not write anything. So my first preference is you check whether home number is present. Okay, if home number they have given, you take that phone number. If they didn't give that phone number, so it will be blank. That column will be blank, right? Then you take office phone number.
Office number.
Okay. If that column also blank, you take the cell phone number. If everything is blank, by default you give like no phone number. So this is what the coalesce function will be used. So something like null value, to handle with null value, this coalesce function will be used in real time. Okay. So journals is nothing but it's a data protection method. So if you take like Oracle or DB2 or anything, so whatever we do DML operations, at the end of the DML operations, we do have DDL is auto commit in Oracle, but in the DML statement is user commit. So we have to commit it, then it will be committed. Okay. So if you are doing something, it will be rolled back. So if you have committed some mistake, we can roll back. But in Teradata, we have the concept of journals. Okay. We don't have in Teradata mode, as we said, so everything is auto commit. Right. So in Teradata mode, so everything is like auto commit. So if in order to maintain the data integrity, we need to go for the journals. Okay, like a data backup. So all those we need to go for journals. So journals are is nothing but, so if we are, it's like a data protection method. If you are anything happened on software or hardware, for example, you are inserting the data or you are updating the data or you are deleting the data. So if you are doing any operations, if anything has AMP failure or anything happened failure, then if you, in order to maintain that data integrity, we need to roll back or like undo or redo operations. We need to do that. Okay. So journals is like nothing but we are like a book we are writing, right? So we are taking some Xerox copy image, right? For example, before updating the front page of the book, you are going to take a Xerox copy of the book so that it will be, the previous state will be maintained. So if anything goes wrong on the whatever you are going to update on the page, you make use of the previous page you have taken. Okay. If you are comfortable that whatever the Xerox copy you have taken, you can discard it. The same way here in Teradata, we have like any interrupted transactions. Okay. So if you have any interrupted transaction or any failure, hardware or software failure, this journals will be taken care. Okay. Takes place automatically. There are three types of journals are there. Okay. Three types of journals are there. So whenever you are creating a table, okay, so you have to mention this journal. Okay. The first one is like transient journal. Transient in the meaning like it's for a short time. Okay, for a short time it will be maintained. And we have permanent journal and we have down amp recovery journal. Okay, DAR, we will call it as DAR. So there are three types of journal. First we will see that transient journal. So transient journal is maintained by system. We are not handling it. It will be maintained by system. So we don't have any control. The system will take care of this operations. Okay. By default, it will take on the database level. Okay. So for example, if you are doing any operations, like you are doing inserting a record or updating a record. Okay. So you are doing some transactions. You assume that you are doing some transactional data. You are sending money to other bank or other account. I see. So on one particular bank. Okay. So it needs like a debit from your account and credit to the account. Okay. So it has been debited in your account. Assume that. But before crediting to that account, the another account, so the transaction has been failed. So what you need to do? So the Teradata needs to take care that it should reverse that operations, that whatever the amount has been debited from your account, it should be to the reversal operations. Okay. So for that, if anything goes wrong, the same way, if you are going to update or insert or any delete on any table, so if it is going to, so if anything goes wrong, it should be undo. Okay, it should be undo on the previous state. So transient journal is nothing but it will be system will be maintained. It will be a short period of time. Okay. The next one is called down amp recovery journal. Okay, this is also system will maintain. So whenever you are maintaining a fallback table, right? Fallback. So you know, right? Fallback. So fallback means, so it's like amp level failure. If you are enabling that fallback, then if any one of the amp has been failed, the recovery will be maintained in the another amp to the image, like another image. It is called down amp recovery journal. Okay, so another AMP, it will be maintained, the recovery. So this is also maintained by system whenever you are enabling fallback.
No.
Okay,
fallback.
fallback. Transient journal, it will be automatically enabled. You are not going to enable it. And we have like a permanent journal. Permanent journal, it will be permanent. So transient journal, it will be short period of time, it will be available. If your transaction is getting success, then whatever the journal has taken, right, it will be vanished. Okay, it will be vanished. Or your transaction got failed, it will be replaced with that, it will be undo to the particular, the previous status. And then after doing that undo, that whatever that the journal it has taken, right, it will be vanished. Okay, anyhow, it will not keep after the transaction failure or success. Okay, but for permanent journal, it will be kept in the system, the permanent space. So user has to enable it. For example, you are going to use this journaling for the very sensitive data. Okay, balance or transaction tables. These tables are very sensitive table. Why? Because the balance will be maintained. Okay, so account holders balance will be maintained on this table. So if anything goes wrong in this table, then it will be very difficult to recover it, right? So so we are going to do any changes, whatever the changes happened for the table level. So it's like balance is getting impacted table level. So at the time of impact, we are going to take the every time, okay, whatever that it is getting changed, every time we are going to take the snapshot, the previous state of the row level or record level or table level.
So while creating the label,
Yeah, we have to enable it. This permanent journal, we have to enable it. It will be permanently available in the database in real time, right? In our real time, the purging will be happened. Purging will be happened. So the permanent journal should be purged. So at some particular time of time, like 1 hour, 6 months once, they will purge. Whichever the journal has been taken, after 6 months, before 6 months, it will be purging. So this is what the three types of journal which is available in Teradata. And also we have two types of images. One is before image and another one is after image. Before image means, for example, you are going to update some record. Okay, you are going to update some record. Before updating it, you are taking some image snapshot. So that will be your before image. For the rollback or undo operations can be done by using the before image. After image means after you are updating, what will be the new data? Before data, after data. So redo. So whenever instead of undo, we want to do the redo operations, you can go for the after image. So these two are the two types of images are available in this Teradata. So journals like a transient journal, I explained, right? What is transient journal? So transient journal is a system journal. Okay, right? It's a system journal. So assume that it provides transaction integrity. Transaction integrity is in the sense like whenever there is a failure or something happened, okay, then it should go for the previous state. Okay, that will be a transient journal. Transient is nothing but for a short period. Okay, and also before image is kept on the AMP. So each and every AMP, the before image will be kept AMP level. So once that the successful or failure transaction happened, it will be vanished. So in case of failure, okay, in case of failure, if you see here, so we are beginning the transaction. So we are updating row A, updating a row B. So while updating a row A, before image will be taken. Okay, before image will be taken. So before updating a row B, we are taking the before image. You assume that there is a failure while updating the row number B. These two are same transaction. These two are same, one single batch we are running it. So if anything goes wrong in one particular failure, then both the cases it will be rolled back. So both the cases will be rolled back. So this is called it will be rolled back to before. Okay, in case of a failure transaction, the data reverted as per the before image. So as per the before image, it will be rolled back. After rolled back, whatever the image it has taken, right, it will be discarded. It will be vanished. In case of successful, update row A. For updating a row A, Before image will be taken.
Updating will be.
Okay, before image will be taken. Whatever the table you are taking, right? Before image will be taken. So you are updating so many records. Okay, updating a row B, something you are updating it. After that, so after updating everything, the transaction has been ended. So it has taken some images, right? It has taken some images. That image will be discarded. Why? Because there is no use of that image. That before journal there is no usage, right? Why? Because the transaction got success. So with that you are not going to use it. So any of it is a success or failure, it will be discarded. But if it is a failure, it will be used. In case of success, it will not be used. So after this rollback operation, the before image are deleted. Clear? For a successful transaction, the transient journal is cleaned after a commit. Even success also, it will be deleted. So every AMP has a transient journal. Every AMP has a transient journal that will be maintained in the DBC's permanent space. So permanent space only it will be maintained. After that success or failure, it will be vanished. That's all. It will not kept permanently. This is what the transient journal. Transient means short period of time. It will not be permanent. So next one is like down amp recovery journal. So what is that down amp recovery journal? This is also system journal. System maintained. So as I told, whenever you are enabling fallback table, the image will be taken in the another amp. Okay. So down amp recovery journal allows continued system operation when one amp is down. So it will be the image will be maintained by another amp in the same cluster. So like multiple amp is there, that is called a cluster. So down amp recovery journals are applicable for tables created with fallback. So whenever you are creating a table with
Where will be the AMPs will be found through this primary index after a hash algorithm?
No. Whenever you are creating the table with the fallback, the down arm recovery journal will be created. So you are not going to use. So even you are using primary index or not primary index, it no issues. So whenever you are creating a table, I told right, in every amp the table will be created. So the copy of the table structure will be created. Okay, whenever you are creating a table, in every amp the table structure will be created. Whatever the data you are going to insert it will be inserted on the particular amp, on the particular disk. So why? Because every amp it has its own structure. So that is what. So if you are creating a table with fallback, so if the table structure has been created in one amp, right? So the recovery journal will be created on the other amp, the image. When we have seen that concept of like fallback cluster. So that is the called fallback. Okay, it is called fallback. So you have to create a table with fallback. So this is what you have to mention. So whenever you are creating a table with fallback, so automatically the down amp recovery journal will be created. No need to create by user. So transient journal, it will automatically created whenever you are creating a table. So you are not explicitly maintaining any method. But this after no before journal, after before journal, dual journal and all, it is the permanent journal. Okay, so this is like where one amp is getting failure, the data will be maintained in the other amp. So we have seen that operations, right? So this is what the down amp recovery journal. Next one is like permanent journal. Permanent journal, we have three options. One is like this is the user level journal, so which is used to protect the data, and also it has three images. One is before image, after image, dual image. The purpose of permanent journal is to maintain sequential history of all changes made to the users. For example, if you take your banking account, okay, banking account, so you are doing some transactions like credit to debit, so many transactions you are doing, but you want to see that what is the your balance like a 10 days before. So how your record is before 10 days, then if they have enabled the permanent journal, it will be available. So 10 previous transaction you can go to the state. So that is what. So but it will occupy more space. So permanent journal has protect the user data when user commit, uncommit, abort any transaction, it will be maintained. So whenever you are doing commit, right, so it will be taken on image. So uncommit, so you are not doing anything, so you have some failure has happened, so it will take on image. Abort the transaction, it will take on image. So whenever there is a change the data, it will take on image. So that image will be maintained for the like data integrity. Okay, sequential history will be maintained. Okay. So it will capture the image like a before and after, before a change, after a change, and both. Like it will be a like before journal, after journal, dual journal. So dual journal means so like a dual copy of the it will take. So when you create a new journal table, you can use several options to control the types of information. Okay, for example, you are creating one table, you can mention like before journal, okay, before journal, or after journal, dual before journal, dual after journal. So what it does mean, before journal means before update or insert or anything happen, it will take one image. After journal means after creating that whatever you are updating, it will take one image. Dual means it will take two copy of before journal, two images it will take. So we are taking some two Xerox copy of one particular document, right? So we will kept it in somewhere. So it should not, it's very sensitive, then we will take two copy. So something goes on one copy also, it will be available one copy. So that is why it is very sensitive data. You can go for dual before or dual after. So you have to enable it whenever you are creating the table. But you must allocate sufficient permanent space. As I told, whenever you are enabling that before journal or after journal, you have to the space is utilized more. This is what permanent journal everything. So before journal means it stores an image. You are clear, right? Stores an image of a table before it changes. Specific point of time. So whatever some error happening, it will specific point of time. So sequential of operations. Okay, it has done like hundreds of commits, hundreds of changes. All the hundreds of changes it will be taken images. This captures two images of a table before it changes. Okay, duplicate images on the two different AMP. If one AMP is failure, the other AMP also will have the duplicate image. So you are having one AMP, okay, one AMP that data is there. So the image will be created on two different AMP. So this AMP failure, the data is there in two different AMP. So that is what the data integrity will be maintained. So remember, the permanent journal must be manually deleted. Okay, manually deleted some point of time. So these are all the journaling concept. So whenever you are creating the table, you have to mention in your journal. So next one, we are having the locking system. Okay, locking. So next one is called locking mechanism. Okay. So this locking mechanism in real time it will be very much important, and also the Teradata will also take care of that locking mechanism by default. Okay. So like whenever locking mechanism is nothing but it's a data integrity. Okay, in order to maintain the data integrity, we are going for the locking system. For example, if we are working in a multi-user environment on the same project, same team, same applications, so multiple user will be working on the same table, right? Same database. They'll be updating it. So all the data integration, all the data updation, deletion, insertion, they will do it. Okay, in the same table. So for example, if we are working on a multiple user environment, if I am doing some update on the table, so I should not allow others to update on the same time, correct? For that, Teradata will automatically go for the locking. If I am updating the record, okay, on the table, so others on the same time they cannot update it. Okay, why? Because it will not maintain data integrity. Okay, so for example, you are updating, you are maintaining like you have mentioned like update table name, set this value where country equal to India. Okay, you assume that you are thinking that country equal to India. I am updating for that India. I am going to update as USA. So another person has update statement where country equal to India. It has some record at the time, but I am going to update like update table name where country equal to USA. Then all the India will be updated as USA. Then when the other person is trying to update it, it will not be updated. it will not maintain the data integrity, right? There will be no record. So, and also might be like data loss also happen. So to avoid this kind of scenario, we are going for the locking mechanism. Okay. So we have four types of locks. One is like exclusive lock, write lock, read lock, and access lock. Okay. So temporary locks can be placed. It's not permanent. Okay. It's a temporary lock can be placed on a data to prevent multiple users from a simultaneous access. So there are four types of access. One is exclusive lock, write lock, read lock, and access lock. Access lock, we will call it as dirty lock. I will tell you why we are calling it dirty lock. I will tell you. There are four types of lock: exclusive, write, read, and access lock. For example, first we will let us see that read lock. What is that read lock? You have one table, product table or transaction table. You are using that select star from the table. Okay, select star from the table. You are reading the record from the table. So while reading the data, so can I allow others to write the data? I'm reading the data. Can I allow other user to write the data the same time? So if I'm reading the data for one reports, so same time can I allow other user to write the data? If I do not want to write the data, then I have to go for read log. If the object is on the read log, the other person cannot write it. Other person cannot write it. Why? Because I have meant for read log. I put it on the read log. So if I put read log, can other user can read the data? If I logged a table for the read log, can I allow
Yes,
other
others
user to
can.
read it? Yes, I can
Yeah,
allow other user to read the log
everyone
data.
can
So
read.
everyone can read. So in case of if I'm the read log, if I didn't put the read log, if other so I'm using that select star from the table, it has been executed at the same time the other person is updating it. So whatever the data I'm seeing, whatever he is updating, it will not be matched. The data will not be at the same, right? Sometimes. So that is why the read and write log are not compatible with each other. Okay. If you have enabled write log, you cannot read it. If you have read log, then you cannot write it. So both are not compatible. Okay. If I go for write log, you assume that write log. So if I'm insert, update, delete operations I'm performing, if I'm going for write log, at the same time I cannot allow for read. If I'm writing it, then they cannot. If they're seeing it, it will be data integrity. They will not see the consistency of the data, right?
Yes.
They will not see the actual data. Some error or the other data might be seeing it. Okay. So for example, you are updating the data or loading the data. It will say like the data is being loaded. So if you are loading the data, at the same time you are going for select start from the table, it will say like the table is getting loaded, the being loaded. You will be getting that particular message. That will be a write log. The database by default will go for the write log. Whenever there is whenever there is a insert, update, delete happens. Exclusive lock is nothing but it is a in the top level. Exclusive lock will be happen whenever you are doing that create table structure or altering the structure of the table. So that time it will happen the exclusive lock. Exclusive lock, no one can write it, read it, access it. Okay, everything it will be happen. Okay, every lock will be the access lock is nothing but for example. So you are loading the data into a data warehouse. Assume that on the Teradata, you are loading the data. So ETL process is loading the data. That means it is writing the data into the table. Before writing it, 7 o'clock it starts right, but 6:59 or 6:58, you want to read the data. Okay, you are reading the data for one reports. It is creating some arithmetic operations on the data or aggregate function is running, so it is taking some time. It is having billions of data. The reading is happening sometime. So at the same time, you want to write the data. Should I allow or I should not allow? You want to read the data. You are reading the data. At the same time, I'm going for writing the data into the table. Should I allow? So what will happen? what will happen? It will go for the queue. Okay, it will wait for the queue. Okay, if I'm reading the data,
Okay.
the right lock will allow you to go for the queue. So you should not allow, you should not, no need to go for the queue. Then you are thinking that, okay, I should not go for the queue. So for example, if the report is being generated on a table, I will apply some read lock. So why? Because I'm reading the data. At the same time, some ETL process is running, wants to write the data. So current day of the data, then it will wait for the queue. No need to wait for the queue. Instead of going for read lock, you can go for the access lock. You can go for the access lock. What will happen? So if you are placing access lock, the other user can write the data into the table. Got it? If you are going for access lock, the other user can write the data, but it
Then
will
how
not.
can we know which lock is presently in our?
So by default, it will take care. By default, it will take care. If you want to downgrade or upgrade the locks, you have to exclusively go for the lock. So you can go for the access lock. So exclusive lock, it will automatically taken. Read and write lock, it will automatically taken. This access lock, we can go for. So you can go for read lock for this table. If you are making that table, the other user cannot write it at the same time. Instead of that, you are going for access lock, the other user can go for the write, but whatever the data you are seeing it might be inconsistency. Why? Because he may update it now. He may update it for current data, right? But you are doing some millions of record on the data. Will be some changes will be there. Okay, for example, you have done access lock on the table. On very big table, you have done access lock. Like it has 5 years of data. You want to do some calculations on the 5 years transaction summary, something like balance you want to check or transaction amount you want to check. So today you are allowing that write operations. Why? Because it's access lock only, right? It will allow you to write into the table. Today's data alone it will write, right? So today's data alone it will be changed. So when compared to 5 years of aggregation, today's data will be very small. Am I correct? So compared to 5 years, today's data will be very small. So so this will be called as dirty lock. To overcome the waiting, access lock can be applied. So it will be dirty lock. Why? Because we are allowing other user to write it on the same time of reading. Clear? So you have to explicitly mention that. So there are the default lock will be there. Whenever you are doing select operations on the table, there will be a read lock will be applied. The other user cannot read it. Okay. Whenever you are updating or inserting or deleting the record, write lock will be applied. The other user cannot write as well as read at the same time. Whenever you are doing create table operations, exclusive lock will be applied. Two users can do the access lock. So multiple users can do the access lock, no issues. These are all the default locks. Okay, default, by default it will take the access. So what are the 4 types of locks? I will tell you. First one, exclusive lock. So as I told, whenever you are doing the table creation, like creation, updation, creation, altering, whenever you are doing that DDL operations, so it will go for the exclusive lock. An exclusive lock restrict the access to the other object with any other user. It will not allow any other user. Okay, it will be exclusive lock. Write lock means other user cannot write it. So whenever you are going for insert, delete, update, the write lock will be applied on the object. So the other user cannot write and also cannot read. If the user wants to read the data, then you can go for the access lock. I told, right? You have to go for the access lock. So read and remember this, read and write will be incompatible with each other.
Can be performed.
Okay, it will be incompatible with each other. All other locks are held in queue until the write lock is released. So access lock. So access lock, I told it's a basic level of lock. We will say like it's a dirty read. Why? Because whatever the data inconsistency, right? So access lock are not concerned about the data consistency. So whatever the data is getting updated, no issues. You are seeing some data, I can say like Okay, no issues. I can see that unupdated data, no issues. Okay, yesterday's data I'm seeing it, no issues. Then I will go for the access log. That is called a dirty reads. So read log is nothing but, as I told, so read logs are used to ensure the consistency during the read operations. If I'm reading the data, at the same time other user cannot read it, then I can go for the read log. And the other user cannot write also. That is what read log will do that. For example, I said exclusive log, prevent any other type of concurrent access. So it's a like top level access. If you put exclusive log, write operation, read operations, access operation, everything will be locked. If you are going for write lock, okay, it will, the other user cannot read it, other user cannot write it, and also exclusive lock also, it will be waiting in the queue. Read operations, so other user cannot write it, and exclusive lock cannot do it. Okay, access lock I so told it's only for exclusive lock. So lock can be applied either in the database level, table level, or row level. So this is what the locking mechanism. For example, so consider this image. You are doing four access, like access exclusive lock, write lock, read lock, and access lock. This is lock level head. Whenever you are holding that none of the lock has been hold. So can I do access lock? Yes, you can do access lock. Access lock will be granted. Can I do read lock? Yes. If none of the access are held it, then you can do that any operation. So exclusive lock also I can do it. For example, if I'm having access exclusive lock on the table, exclusive lock on the table. Okay. So can I do that? So you have done access lock. So something like access lock. Assume that I have done access lock on the table. If any exclusive lock is coming, it will be queued. Okay. So you can do that access lock. It's compatible. Read lock can be done. Write lock also can be done. If you are making like read lock, read at the same time, access can be done, read can be done. Other user can read the data, but other user cannot be write it. It will be on the queue. On the same way, the exclusive lock will be on the queue. If you are doing write lock, only access lock can be applied. Read and write lock, the other user cannot read it. Can be done right. Dirty reads. I told like it's a dirty reads.
Oh, dirty reader. Oh, okay.
Okay, so if you are reading the data, if you are making like read lock, so other user can be doing some
During
read.
the access log, yeah, someone
They
can
can use it.
while
Okay.
reading.
The write log is like if you have done write log on the object, the access log can be granted. Okay, it can be granted, but read log and write log exclusive log will be queued. So if you have done with exclusive lock, you have taken exclusive lock on the table, then all other operations should be queued. It should be, so you are creating the table. After creating the table only, or after altering the table only, any other the locks can be applied on the table. Okay. So you asked, right, how can I lock the table? You have to use this way. So whenever your session got completed, this lock will be automatically released. So locking row for access, locking table B for exclusive lock. So locking row for read. This is what you have to make. Okay, whenever you are writing query, right, you have to, if I want to do the read lock, then you can go for locking row for read. Select star from my table. So others cannot read it. So this will be maintained in the multiple user environment. In our environment, we cannot practice it. So because multiple user environment, the other user cannot read it. If you go to any project, you can see this type of operations. Okay. So this will be a locking mechanism. So next one is like merge statement. So merge is nothing but whenever you are going for any ETL process, right? You will do the merge operation. Okay. So you have one table, consider. So merge definitely you will use in real time. Okay. Merge operations. Remember the syntax. So you have one table here. You have another table here. So this is like work table. You assume that this is a work table. This is final table. It's a final table. So this work table structure is same with final table structure, provided the work table is having only today's record. The final table has some 10 years of data, or like 1 year of data, all the data to have. But the work table is having today's data only. So I'm having a record here. For example, 100 I'm having, 101 I'm having. So 102 I'm having, 103 I'm having. Like this I'm having first time. So I will check whether the 100 is present here. If it is not present, I will insert it. If not present, I will insert it. 101, 102, and 103, I will insert it. So if not present, I will insert it. So the next day you assume that the green color is next day. Okay, next day new data is coming. Okay, 104 is coming, 105 is coming. Some update is coming with 102. This is like update. Update is coming with 102. So what will happen? I will check this record is present or not. If not present, I will insert it. If not present, I will insert it. 105 also I will insert it. If I have some update on the record, I will go and update it in this record. I will check whether this record is present already. Yes, it is present. This record is already present. Some update is coming today. I will check this record is already present. Yes, if it is present, then I will update it. This is what the merge. You should not again insert it. Okay, why? Because it's a primary key column. You cannot insert it. We'll go for updated. So this is what merge operations will do. So merge operations. This is what will happen. So the syntax of the merge is merge into target table. Merge into target table. So using source table. Using source table, we are merging the target table in using source table on condition. So based on this condition, this common the key column condition, this employee ID or product ID equal to target product ID. So whenever there is a match, then only we are going for. So condition we are making it in the bracket. Condition when not matched, when the condition is not matched, then we are going for insert operation. Matched, when the matched, then we are going for update or delete. Okay, I will take the table called customer join. Okay, it has some customer data, right? Select start from customer join tree. I will take. So it has some data. Assume that. Okay. I am going to create same table like this for merge table. So I will create two types of table, same like this table. Create table yes underscore customer underscore merge as customer join tree. Okay, I'm creating that. I have created one more table. I'm creating with t underscore customer underscore with no data, comma primary index. What is the index field here? Customer ID, right? So I have created two tables. Now look at the table. Select star from this table. You have the table like this. Okay, I have 8 records. And this table I will not have any record. I will not have any record. So I'm going to write a merge statement. Okay, what is that merge? So merge into this one, target table, right? Target table. I will call this table as T. Okay, this table using source table as S. So be S on condition on S dot customer ID equal to T dot customer ID. When not matched, then insert. So you can directly insert values. Okay, values. While inserting it, you will insert all the record. Inserting it, you will insert with customer ID also. So S dot cust ID, comma start cust ID, S dot cust name, right? You have to use cust name, S dot mobile number, S dot email, comma S dot city ID. So this is what insert operations. Okay. Then update operations also you can go for. When matched, then you can go for update. So update set. Okay, set. No need to update the customer ID. Why? Because the customer ID only it's a common column. So you should not update the customer ID. You cannot update it. So s dot customer name. T dot customer name equal to s dot customer name. Whatever the T is having, right? T dot name equal to s dot name, comma T dot mobile number. MOB mobile number. T dot mobile number equal to s dot mobile number, comma T dot email equal to s dot email, comma T dot city ID to s dot city ID. So this is what you have to use it. So this is what the merge statement. Clear? Sometimes you will maintain the column name also. Insert column names values. Okay. So if I'm going for merging, it will merge 8 record into the table. Before merging, I will show you that it doesn't have any record, right? It will merge. So it will merging. See now. Target no need to mention. Why? Because here we have mentioned. Okay. Here, if you check the target table, the 8 rows will be merged. Okay. If again, if I'm going to execute, it will merge 8 record. Again, if I'm going to execute, again 8 record will be maintained, merged. It should not happen in real time. So for that, we are going for minus operations. If both are equal, you should not merge anything. For this, using this one as yes, right? So what we are going to do, minus operations, like select source minus target. If you are making this way, no record will be maintained, right? Select source minus target. If you are doing this way, select source minus target.
Select star from target minus.
No. Source minus target I'm doing. If you are doing source minus target and you have 8 record is there in the source, target also 8 record, you will not get any record, right? So if source is 9 record, target is 8 record. That means 1 record new. So that record alone we can go for the insert or update, right? Why do we need to go for all the record? So instead of going like this, we are going for minus operations. Then it will not merge anything. See now. So even though both are equal, before that it is merging, right? Now it will not merge anything. Merge completed 0 rows. If any record has been updated in source, for example, in the source I'm going to update record. Something like instead of Sri, I'm going to use another name. Customer name equal to John. I'm going to use it John equal to Sri. So one row I'm going to update it. So this is only one row is updating, right? One row got updated. If you are doing this operation, it will do 8 rows merged. Okay. Instead of that, if I'm going to execute, for example, source minus target, that one row alone will be taken, right? Why? Because that is the one row is changed whenever you do source minus target. So if I'm go and update, so merge, it will do only one record, not all the record. So here, if I do this operation, it will do only one row merged. Instead of that, if I go for this one, if I'm not going this one, instead of this, if I'm going this way, 8 record will also merged. So for example, I'm going for some other, instead of updating one row, so previously I have executed this one, so one row processed. If I execute this one, all the 8 rows will be merged. See now. So that is why in real time we need to go for this type of query.